Hello, hello, hello. Hopefully this is working. Okay, I'm just setting up LeetCode. See. Okay, so okay, what is today's goal? Basically, tomorrow we have LeetCode's contest, right? Weekly contest here. Tomorrow at 8 a.m. we have LeetCode's weekly contest. So for that, I need to practice some questions, right? So I have this website, Zero Track LeetCode problems, where you can select a rating interval. Now, what's my rating currently? It is 1665. So I can set the range. I would go for 1400 to 1900 and set the range. Okay, so I have these variety of questions, a lot of questions. I will aim to solve as many questions as possible today. And what I've learned from yesterday's and day before yesterday's stream is that I'm spending a lot of times on a single problem. I need to speed that up, right? I need to speed it up. But before that, I need to solve today's daily problem. So let's see today's problem. We have count partitions with maximum difference at most k. Okay. Yesterday we had count partitions with even some difference, which was easy. Today we have a hard medium problem, which is 2000 plus rated. Okay, let's see. We'll minimize this. Okay, done. Minimize this. Okay, let's see. Problem 3578, count partitions with maximum difference at most k. Okay. You are given an integer array nums and an integer k. Okay. Your task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between the maximum and the minimum elements is at most k. Okay. Return the total number of ways to partition nums under this condition. Return, okay. After reading this line, return the total number of ways to partition nums under this condition. What I feel is that we can do a DP, right? We can solve using DP, which is just in a given range, find the min max value, iterate over the loop. Okay, so we have a function iterate over the loop, and if we find calculate the min and max, and then what do we have to do? Mm, okay, and if it is less than k, we just call the function again until we reach the end. When we reach the end, just return 1. That's what I can think of as of now. But let's see, what are the constraints? 5 into 10 power 4. But oh, but nums is 10 power 9. I don't. Oh, K is also 10 power 9. I don't think it will be dp because of the constraints. K is 10 to the power 9. We cannot store that many states or different states of K, right? In an array. Oh, this is a good problem. You're given. Okay. So the brute force approach is obviously to n square over this, over the array, and then find all the possible uh what do you call partitions which will satisfy this condition, right? Hmm. But we cannot use the brute force because constraints are high, 5 into 10 power 4. If we try to n square it, it will cross the 10 power 8 limit. So we need to find an optimal solution. Okay, let's see this example. K equal to 4. So the difference between the max and min should be at least 4. We are at 9. There are 6 valid partitions where the difference between the maximum and the minimum elements in each segment is at most k. Previous segments of each segment and the difference in the maximum elements at most k. Okay. At most, so it should be the difference should be greater than equal to k, greater than equal to k. Okay. So we can form individual partitions. How is one? No, most, not at least, but no. So it should be less. Should be less than k, less than equal to k. This, this, okay. Mhm. Can take this. Okay, we have 4 comma 1, which will give us 3. Obviously, 3 comma 7 is going to give us 4. This is 2. This is 3. This is 3 and 4. This is 0. Okay. Hmm. Since the answer may be too large, return module. Just let's just declare this right now. Then 1, 2, 3, 1, 2, 3, 1, 2, more. Okay. Hmm. Can we use Collins algorithm here? Hmm. And max difference. It must be. So here we just check 4 minus 1, which is okay. Hmm. So what I can think of is, let me turn on my camera. Best view. Hmm, hmm, so this- oops. Okay. Hmm. So what I can think of is, we have this array. Can you all let me just turn this on? Hmm, why is this not working? Okay. Yeah. So we have this number 94137. Okay. Now we just need to keep a track of the minimum and the maximum numbers, right? So we are standing at 9. We are standing at 9. We can say that, uh, hmm, what can we say? If we are if we are at 9, we look ahead and check if the minimum minus maximum value is minimum minus maximum value is at least at most k or not. In this case, it is 5. So the condition doesn't satisfy. If the condition doesn't satisfy, hmm, but we cannot be greedy. This is a what I'm trying to do is use greedy algorithm. But we cannot do that because suppose in the future, if we get a number which is no, wait, this is if this is the minimum, 4 is the minimum. Yeah, if 4 is the minimum, we cannot find a number which is more which is which is smaller than 4 and will give us a number which is at most k. The difference will not give us a number which is at most k. We need a bigger number, right? So this is guaranteed that this subarray will never give us the maximum difference at most k. Hmm. So we start a new array from 4. What do we do here now? We are at 4. We look ahead. We take an element, which is 1. Now we subtract 4 with 1. Okay. And now this it satisfies the condition. This maximum is 4, minimum is 1. So the answer is 3. It satisfies the condition. So we'll count this as one we'll count this as one subarray. No, one partition. Like one case where you can form the partition. So basically what we have done is considered this case as of now. Hmm. Okay. Now we have the maximum value set max value set to 4. We have a min value set to 1 currently. Now we move ahead and go to the third index. What does the third index say? Wait, I can do something. I can just guess. Oh wow, I cannot see anything. I'll see. Yeah, hopefully all can see. Okay, if I take this 3, the max and min value doesn't update. So we have max set to 4, min set to 1 again. We take this element and say that, okay, we increase the sub count. Now we have 3 elements. Now 3 elements, using 3 elements, I can say that we can create 2 partitions, which is 4, 1 and 1 comma 3, 4 comma 1 and 1 comma 3. This is a valid partition. So 4, wait, 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 4 comma 1 and then 1 comma 3. Where is 1 comma 3? Yeah, we have 1 comma 3. 4 comma 1. So this is checked off. This is checked off. Now, and this. Now, so our current, what do you say? Our current count, our current count is set to 2. Now, we move ahead. We see that we have a max value of 7 now. So the max value gets updated to 7. But now 7 minus 1 doesn't satisfy the condition. So we don't update the value, right? We don't update the value. Hmm. But then what can we do? Since the this condition doesn't satisfy, we try to maximize the min, right? We want to maximize the min. So what we do is we store the index of min, and then when a case comes where where it doesn't satisfy the condition, we just update the value. We just what can we do? We just update the value of min's index from this I to I plus 1. So currently min is at 3. And then but we need to check if there are any smaller elements than this given 3, because there can be a case where the numbers are small. But what I think is I'm complicating this problem, because if we follow the 3 golden rules, that solutions are simple, implementation is simple, and code is simple. I forgot the third one, but you get the point. Uh, I am overcomplicating this problem. Hmm. Okay, I think I've spent well enough time on this problem, around 20 minutes. I think I will look at the solution now. Let's see. Just a moment. Hmm. Okay, open this. Cool.
Hello,
Let's see.
hello, hello everyone. I hope you are doing well. My name is Sayam and welcome back me guys. This is very interesting problem. This problem like तो I would rate it as medium hard category. Actually it's a hard problem. It is a hard problem. But अगर तुमने कुछ पहले इस तरीके का प्रॉब्लम सॉल्व कर रखी हो, the mixture of two concepts like just like a JEE advanced problem, multiple mixture two concepts mix करके अच्छा problem मैंने frame किया. We'll see the detailed intuition how we will reach it. We'll see step by step some root solution, some better solution and optimized solution.
Hmm.
Step by step पहुंचेंगे and एकदम intuitive तरीके से पहुंचेंगे. And trust me guys, after watching the complete video with understanding bits and pieces, don't jump to the optimized solution. Just a small request because you will understand how we reach it. Now people will comment, oh how we reach is optimized. Trust the process, go the process, and then you will understand it. Right? Let's get started then. Cool. The question is, you're given an integer array nums and an integer k. Perfect. You task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between the maximum and the minimum is at most k. What does that mean is you have to divide your array into multiple segments such that the difference between the maximum and the minimum of each segment must be at most k. Perfect. मतलब उसका जो maximum है maxi minus mini, obviously
Hmm.
maxi mini से बड़ा ही होता है, तो उसको डायरेक्टली मॉड लिखने की जरूरत नहीं है. ये केस है, छोटा होना चाहिए.
Hmm.
Perfect. Return the total number of ways to partition it under this condition. Okay यार. Since the answer will be too large. Okay. ठीक है. अब जैसे ही तुमने ये रीड किया कि 10 पावर माइनस प्लस 7 से मॉड लेना पड़ेगा, पार्टीशन करना है, you should try to think about, okay, we have two number of ways at partition means at every index I we have two choices, either we need to partition it, partition, or no partition. I hope you're getting it. No partition, absolutely right. That gives a feel of a recursion, DP, something like that, right? Because we have
Hmm.
to try out all the possible ways,
Yes.
we have to try out all the possible ways. But wait a second, let's go to the constraint. And
Hmm.
constraint make me sad. Constraints बोलते हैं, constraints हमेशा की तरह धोखा देते हैं, but life में धोखा नहीं मिलना चाहिए guys. So 10 power 5 or 10 power 4 is the constraints. That means we cannot apply a recursive solution at least. Okay, we cannot apply a n square solution also. But let's try to think about and calmly how can we think about it. If we apply this
Hmm.
approach, the partition not partition approach, can we get something? We won't reach the optimal solution, but at least we can try because that will make the concept more clear that how we reach the optimal, right? Okay. So what I told, it's a pick no pick like a problem. It's a
Hmm.
partition no partition problem. So you have two choices. Either you can partition it
I don't
or
partition
either
it.
skip it.
Hmm.
Right. That is the two choices. But
Hmm.
only you can partition only when maxi minus mini
Is less
is
than
less
equal
than
to
equals to k.
k.
That is the
Hmm.
idea. Skip to you can do always, anytime.
Hmm.
That is no condition required, right? Absolutely. So what we can do is we can partition it every point. So we will make a DP of I that will tell us the number of ways to partition at given index at till you can say till ith index perfectly.
Oh, wait. I said that The k will not be a state, right? Because k is a constant value. We just need to find a number which is less than equal to k. But yeah, but this is again, this is DP, right? Uh, How can we solve in these constraints? I mean, it, I think I had read somewhere or saw a video where it said that constraints up to 10 power 5 for DP, you can use DP for constraints up to 10 power 5. But I don't know. Let's.
fine, perfectly fine. You can do that. Now, the problem is to maintain this maxi minus mini.
Hmm.
People can think, Isayam, it is very, very simple. What you can do, you can make a maxi array. Till ith index, you can get it a mini array. Till at ith index, what is the minimum value? You can create that. And you can easily compute maxi minus mini, the condition you can check. But wait. The problem is, let's say 2, 3, 4, 5, and 6. It's like this. When you try to partition it here, your maxi and mini changes. This is a separate partition. And we are talking
Hmm.
about the maxi and mini of a new fresh partition. Now, here, the mini is not 2. If you do think about this partition,
Hmm.
the mini is 2, 4 here and maxi is 5k if you talk about this partition. That's why that logic of maintaining like a pre-computing array of maxi and mini won't work. That we got it. Same then also it is very simple. What I will do, I will write a recursive function with the optimized DP part. What we can do, I can write an int solve function. And what I need to maintain only an index because we need to partition it. Pick or non-pick logic, right? And nums we needed a vector. In nums we needed. Otherwise, we don't need anything, right? Okay, also we need, so we can keep the k as well. So we can keep nums and int k also. Absolutely fine. And then what we can do, I'm not writing the other cases. I'm just writing, okay, now what we can do is we have want to maintain this maxi mini logic. Now we, for every j, see, for a given index I, I'm finding the partition index j, whether we can partition it or not. That is the idea, right?
Hmm.
We can partition it or not. So what we can do is for every index, what we can do, we can maintain a mini starting with the current thing. We can starting with the current thing, which is nums of I, and same the maxi also equals to nums of I. And what we can do, we can find of j for doing the partitioning thing, for int j equals to I. You can start the partition from the current index also. You can partition it from the current index also because there is a valid, this is a valid partition, right? J less than n because we want larger than that. Then we're gonna do j plus plus. And what we're gonna do, we're gonna update these things. Mini will update it, and maxi will update it. What with what? Mini with minimum of mini, comma nums of j, sorry. Or similarly, maxi with maxi of maxi of and nums of j, right? If
Hmm.
at any point of time the partition, because we are j, we are going on the right way direction, right? We are going on the right way direction. We're fixing I, we're finding the right index. So what will happen? At any point if max
But that's the problem, right? This becomes O of n square. Like you're calling the recursive function. Uh, As of now, he's not calling the recursive function, but he will call the recursive function, right? You're calling the recursive function and then iterating over using a loop, for loop. This is O of n square, which will not pass, but let's see.
minus mini is greater than k, we have to break it out. We have to break because we can't go beyond that. We can't go beyond that. I
Hmm.
hope you understand why. Because the further partition won't be valid. Because if एक भी partition invalid हो गया, the whole partition logic is absolutely absurd. Absolutely right. Absolutely right. This is the breaking condition. Otherwise, what we're gonna do? This is where we do the partition. So we initialize a ways answer, number of ways to calculate our answer. Let's say 0 here. When we're gonna sum up over all the possible ways is equals to ways plus solve of. Now, since now the next index become j plus 1 because till j
Hmm.
we did a partition j plus 1 and just write everything, whatever is the remaining nums and k. Right. This is the answer. And finally, after this for loop, what you can do, you just return the answer. This is all inside the for loop. So you can say that everything what we wrote here.
Wait. So you found minimum and maximum till n. So what I can understand is from this, like we can from it. Hopefully all can see this. Yeah. Is this quality? Oh my god. Just need to check. Is this quality? Oh my god. Okay, never mind. It's Hmm. It's fine. Okay. What Okay. So what he is doing is, imagine we have this nums array. We are iterating. If suppose we are at I, this is I. He's finding the min and max from I till the end of the array. But there are different possibilities, right? We can partition it here. We can even partition it here. Also, we can even partition it here, right? So, but what he is doing is directly going to the end index and finding the min and max, which I don't know. This is not right, right? Because you need to find all the different number of partitions. So basically, J can vary here. J can be this, or J can be this, or J can be this. So let's see. That mean what it does. Let's see. Don't know yet.
This is inside the for loop, and this is outside the for loop. This is outside.
Hmm.
This is the idea. Let's try to think about what are the base cases we can think of this recursion.
Oh, so word. Okay. This looks good.
Base
Okay.
cases, Sayam, it is very simple. If we reach till end successfully, if we
Hmm.
reach till end, that means this is a valid partition.
Okay,
This is
this
a
is
valid
a
partition.
half
And
and
what we're
square
gonna do, we're gonna
solution.
return a one. That means, see, when you are doing the count problem, जब भी तुम count वगैरह की problem solve करते हो ना कि
Hmm.
कितने ways हो सकते हैं, and you try out all the possibilities and you sum them up. Always go your base cases when you reach the last index, which is the nth index. If
Return
I
one.
equals to n, you're gonna return one because this is a value. अगर तुम पहुंच गए वहां तक, that means this. Otherwise तुम पहुंचते नहीं, क्योंकि तुम यहाँ से देखो, यहाँ से तुमने क्या किया, ब्रेक कर दिया ये वाला लॉजिक से, तो तुम आई जो है लास्ट इंडेक्स पे पहुंचते ही नहीं, तो काम होता ही नहीं. एब्सोल्युटली राइट. और ये भी तुमको समझ में आ गया कि j+1 क्योंकि टिल j तुमने पार्टीशन कर लिया, एंड आई से उसके बाद तुम बाकी जितने भी पार्टीशन है उसको अपन कैलकुलेट कर सकते हैं, वी कैन गोना सम दिस टू गेट आवर फाइनल आंसर. सो व्हाट वी डिड नथिंग, वी जस्ट फ्रॉम अ पर्टिकुलर इंडेक्स I, we gonna partition it from I+1 till whatever we want, till j we partition, मतलब कहीं भी कर सकते हो, till n you can partition. When there the condition won't break, अपनी condition break नहीं होनी चाहिए, the partition करते जाओ and sum all these ways, sum all. And for each I we are doing that, for each I we are doing, and finally what we are doing for I equals to this is a recursive function, right? This is a recursive function. So what we want the partitions till dp of n minus 1. Or you can say directly it will do the recursion stuff also कि जितने भी अपन को partitions अपन को मिल चुके हैं. I equals to you can partition when there the condition won't break, अपनी condition break नहीं होनी चाहिए, the partition करते जाओ and sum all these ways, sum all. And for each I we are doing that, for each I we are doing, and finally what we are doing for I equals to this is a recursive function, right? This is a recursive function. So what we want the partitions till dp of.
Oh wait, I understand it now. What he's doing is check up till n, but the thing is, if we if at any point we find a value, a condition where max minus min doesn't satisfy k, if we go till the end of n or the end of the array, will never ever satisfy the condition, right? So instantly break from there. Uh-huh. Yes, that makes sense. Hmm. Okay.
n minus 1. और you can say directly it will do the recursion stuff also कि जितने भी अपन को partitions अपन को मिल चुके हैं वो अपन को finally मिल जाएंगे. तो I तक कितना हो गया, n minus 1 तक कितना हो गया, और इसके अंदर उल्टा हो जाता है. You can do that dp of 0. This is our recursive state. This is a bottom up approach, or this is our top down
Top
approach.
down
Top
approach.
down approach. This is how we do it, because we pass the 0th index and then finally it will create our answer. I hope you get it. कि what we did, we just finally just did it that okay,
Yes.
अपन एक maxi minimum चला लेते हैं क्योंकि
Hmm.
this is creating for each I. We are finding an optimal j, how many j's we can get it, and for
Hmm.
each j we are just summing up the answers.
But this is the last condition, right? Wait.
चला
Okay.
लेते
So this is inside the for loop, the solve function. Yes. I thought this was outside the for loop. That's why I got confused. But yeah, this is inside the For loop, which makes sense, which is correct. Okay.
Then this is creating for each I. We are finding an optimal j. How many j's we can get it, and for each j we are just summing up the answers, and finally अपन को जो DP of 0 वाला जो है वो recursive state है, वहां से अपन को आंसर मिल जाएगा. But the problem is, now people will think same. It is very simple. The time complexity is over and only, right? We just only use one state.
Nope.
Nope, you're absolutely wrong here. See, whenever you calculate the time complexity of a DP solution, you always have to think about the time complexity of the states multiply by the loops used inside the loop. Since this is an n loop, the time complexity becomes n into n, which is n square. That is the problem. And that's why I told people that don't try to rely always on recursive solution. This is not a recursive solution. N square, definitely it will work. Let me just quickly show you the code also. That this is the code of the optimized DP part. That what we are doing, we are just finding the long number of ways. If it is greater than k, we're just making it up. Otherwise, we're just summing up all the possible ways. For this particular I, we're finding all the particular j's and then finally summing it up, right? And then finally returning the zeroth index answer, because this is a recursive solution, right? This is how we do it, and maximum minimum. But the problem is this loop part. This is not optimized. We're going for every j, and this is compromising our complexity to n square. Can we get rid of this loop? Get rid of this loop. Okay. This is very intuitive to think, at least till now. Now the other part I will tell you. See, the problem in these kind of question happens is now people cannot think beyond this. Why? Because they always know the recursive solution. They don't write iterative solution. Now optimizations can only happen in iterative. We cannot write optimization in this recursive solution. We cannot improve this here iterative solution. Now optimizations can only happen in iterative. We cannot write optimization in this recursive solution. We cannot improve this here itself. We have to write the iterative thing. Now let's try to understand what is happening in the iterative fashion. ठीक है? अब iterative अपन समझने की कोशिश करते हैं. अपन ने बोला क्या? अपन ने बोला कि dp of I plus I लिख लेते हैं is the number of ways to partition till index I. ठीक है, इस तरीके से वाली अपनी बात होगी. दिस वी नो दैट. अब इसको कैलकुलेट करने के लिए मुझे तुम ये बताओ कि जैसे लेट्स से मैंने पार्टीशन ले लिया, प्रॉब्लम क्या हो रही है, 3 4 2 5 7 8 ले लिया, तो इसका इस वाले इंडेक्स के लिए कैलकुलेट कर रहा हूं, तो मुझे ये बताओ इसका आंसर किस किस स्टेट्स पे डिपेंड करता है कि मैंने कहां कहां पार्टीशन किया था लास्ट टाइम. राइट राइट, कहां कहां मैंने पार्टीशन किया था उस पे ये डिपेंड कर रहा है. एब्सोल्युटली राइट. तो कैन यू टेल मी दिस थिंग कि अगर मैं इसको ऐसे लिख दूं, डीपी ऑफ आई इज इक्वल्स टू समीशन ऑफ L till I dp of, let's say you can say k equals to L to I. इसका क्या मतलब हुआ? इसका क्या मतलब हुआ? You can say I minus 1, but I भी कह सकते हैं कि अभी I तो 0 ही है. इसका क्या मतलब हुआ? मैं ये बोल रहा हूँ कि अभी तक अपन ने जितना भी अपन ने j यहाँ तक ढूंढा, यहाँ तक जितने भी अपने वेव पार्टीशन किया, उसके पहले तक अगर अपन ने इसको एक्सटेंड किया इस वाले I तक, अपन करना क्या चाह रहे हैं? अपन बोल रहे हैं दिस इज द I. I want to find L index or you can say J index, you can say J also. Let's say ये J index है. अगर मैं इसके पीछे गया, then my this condition will break. Maxi minus mini greater than k, ये वाला कंडीशन ब्रेक हो जाएगा. I want to find this optimal j, that this is the last index where this is condition is being satisfied. Means our condition would be ये अपनी condition satisfy हो जाए. I want this. I want to extend this j as left as possible. जितना लेफ्ट में हो जाए उतना पॉसिबल हो, उससे मेरा काम बन जाएगा. Then how it will help us? It will help us very easily, right? Because आंसर फिर अपन इससे जितने भी प्रीवियस अपन ने कैलकुलेट किए हैं उन सबसे अपन को आंसर मिल सकता है, right? Because you can partition it here, then here, then here. Because जितने भी partition अब तक अपन ने किए हैं वो वर्क करेंगे. Why it will work? I hope you are getting it. It will work because this maxi minus mini condition is being satisfied, and we already know the answer till these indexes. The indexes are like this dp of I is actually is equals to dp of this j till jth index plus dp of j plus 1 plus dp of I. dp of I is still 0, you can say that. So there's nothing. You can take I minus 1 also. That is also fine. That is not a big deal. But the idea is this. How it will help us? Because see that the nums of the I से जो j वाला जो अपना Subarray है, right? The Subarray is satisfying this maxi minus mini less than equals to k condition. Now, if I push this j at a one step beyond that, like if I do just j minus 1, left one side, it won't satisfy. It won't satisfy. We have to find this j actually. Won't satisfy. That is the idea. Let me just show you with the help of an example also. Let's say this is 3, 4, 5, 4. Right? Let's say our k is equals to maybe, let's say, or maybe you can say, let's 1. Okay. So we are at this index. Okay, let me just make it 2 also. That will make things more clear. So let's say we are at this index. Okay, fine. We are at this index. Now, what we have to maintain, and we have to see that initially, or we can start also, that will understand you better. Let's say our j's start with 0, because initially I also start with 0. Right? And we're gonna search like this. कि कितना last j अपना possible हो सकता है. Fine. This is our answer. So j won't increase because अभी तक अपन ने j ये रख रहे थे. अपन j को move करेंगे rightwards if it is still satisfying, because अपना I तो आगे बढ़ता जा रहा है. I तो every time it will increase. J will increase if it won't satisfy the condition. ठीक है यार. अपन अब इस I पे पहुंचे 2 3. क्या maxi minus mini satisfy हो रहा है क्या? हाँ, satisfy हो रहा है, कोई दिक्कत वाली बात नहीं है. तो J को अभी भी मैंने 0 पे मेंटेन करा हुआ है. Our J is maintained here itself. Cool. अभी अपना I इस पे आ गया I. अब देखते हैं क्या अब satisfy कर रहा है क्या? नहीं, अब satisfy नहीं कर रहा है. That means what? I have to move this J. To this position. And I have to check the condition whether it is satisfying. Yes, it is satisfying. So I can compute that. And now from here, I know that all the possible answers, it will finally really satisfy the result. The result is maxi minus mini is less than equals to k. That means if we know the j, we just need to calculate this prefix, this sum. dp of I equals to dp of j plus dp of j plus 1 till dp of I. Okay, but there is a problem. What is the problem? The problem is if you will iterate on this, then it again becomes n square solution. We don't want that. यही तो अपन को चाहिए था कि अपन को ये बार-बार समना calculate करना पड़े. That's why, see, this is a very standard problem and very important to understand. If you like, this is a actual OA problem, kind of problem. It will happen because this will make the difference. So what you have to do, you have to maintain the prefix sums of the TP. Prefix sum of TP. That is the idea. So how you can calculate from the prefix sum is very simple. TP of I equals to what? Prefix of I minus, you can say that
j
prefix of
minus 1.
j minus 1. That is the idea. Right? Till j to I अपन को चाहिए, तो अपन इसको I से prefix of I minus prefix of j minus 1, then that will, this is how we calculate the subarray sum, or you can say the sum of a subarray using range sum, right? Using this prefix things. So this is very important. How we'll calculate the prefix? The prefix is very simple to calculate. Prefix is what? Prefix of I. This loop logic. We are not iterating for calculate it. So that is the idea. How we optimize this? See, we bypass this loop logic. We are not iterating for all the j's. We're not iterating for all the j's. We're just finding this optimal j, and then we can calculate this sum. Because see, this is contiguous. We can store it in the prefix part, and you can calculate in O of one time. You don't need to iterate. And how can you get this j? This is can be done with the help of a multiset. A multiset. That is the idea. Multiset, right? So what we can do is we can maintain this multiset. How multiset will help us? It will help us to resolve the problem of maxi minus mini
What is a multiset?
condition check. ये condition भी तो check करनी पड़ेगी कि less than equals to k है कि नहीं है. That is, it will help us. So let me just quickly summarize this problem for you in a very small detail. Right? देखो, अपन ने start किया n square problem से, n square solution से. कि n square तो अपन ने समझ लिया, उस loop को हमको eradicate करना था. अब हमको ये समझ में आया कि dp of I का actual मतलब क्या है. dp of I का मतलब है कि till ith index how many partition I can make. Right? This is the meaning of dp of I. I तक reach करने के लिए I can calculate कि कितने partitions में कर सकता हूँ अलग-अलग तरीके से. अब इसका आंसर में डिपेंड करता है dp of, let's say कुछ k मान लो, k belongs to some this l, or you can say this j, till I, ये कितने partition में कर सकता हूँ. I पे भी partition कर सकता हूँ, I minus में भी partition कर सकता हूँ, I minus 2 भी partition कर सकता हूँ, till j पे partition कर सकता हूँ. इन सब का वैलिड रहेंगे. Till it is valid means ना, ये जो अपना j to I सब array है, इसमें वो condition satisfy हो रही है. But the problem is how we'll find this j and how will the find this sum. These are the two problems we have to encounter. Now to maintain this j, we have to use the multi-side thing. The multi-side thing. It will tell us, okay, how we can find this j. Initially, we'll make this j equals to 0. And if the condition is not being satisfied, we'll push this j rightwards. It's like a sliding window, rightwards. It's a variable and sliding window rightwards if condition is not satisfied. Condition, because what we are doing, essentially shrinking the window, condition not satisfied, right? Absolutely. And सबसे बढ़िया फायदा क्या होगा? Starting में रहे, that would be more larger subarray, more answers, because what we are doing, smaller the j, more the answer of the more number of ways to partition it, right? That is the idea. अब j to I is the last subarray that is satisfying the condition. Otherwise, if we do a slide thing, we cannot add dp of j minus 1 because it is not satisfying till ith index, because ith element we have encountered in our subarray. That is the idea, okay? Or you can say number of partitions. So we cannot include this j minus 1. Okay, yaar. And then to maintain this sum, we use the prefix sum wala logic, right? This is the overall idea. Now the important thing is, for making the things more clear and easy, we have used one base indexing. So instead of representing dp of I with I am representing with dp of I plus 1 to represent the one base indexing. And similarly for the prefix thing also. I hope you will get it. Okay, this is our multi-set that we are maintaining for maintaining the minimum minus maximum.
Okay. Oh, this is a difficult problem.
And this is our j, that okay, which is the last valid j. Initially it will start with 0 itself because this is our answer. And let's try to understand. Okay, so we go to 9 and we insert into our set, and then we'll check. Okay, we have to calculate this dp, right? Dp will be what? J is still remains 0 itself. There is no change in j. So what we essentially are doing, dp of 1 is equals to prefix of 0 minus 0, because j is still 0. There is no prefix of j minus 1, right? So this dp will update this with 1. What will be the prefix? Prefix is previous prefix plus current dp. The prefix will become prefix j is still 0. There is no prefix to prefix of 0 minus 0, because j is still 0. There is no prefix of j minus 1, right? So this dp will update this with 1. What will be the prefix? Prefix is previous prefix plus current dp. The prefix will become 2. Absolutely fine. Okay, let's move ahead. Now, if we go to this 4, try to observe this. We insert 4 here. Maximum minus minimum from this set, we can see it is greater than 4. It is 5, right? That means what? We have to increment this j. We have to push our j to the right side. Also, we have to remove this 9 from our multi-set because this is no longer our part, right? So this will be itself 4, and our j will increment to 1. And then how will we calculate our dp? dp will be prefix of I, which is like 1, right? Prefix of I, because we are standing at what? We are standing it here. So prefix of I, 1, and minus, actually it should be 0. Wait, I am standing at I equals to 1. So I itself, oh sorry, yeah, it should be 1 itself. Already did a 1 base index in 1, minus prefix of j minus 1. J is 1, so it would be 0, and 2 minus 1 equals to 1. And does it make sense? It does. Let me just show you also. This will be 1. See, when you are standing at 4 and you have to calculate how many partition you can calculate the partition is like this: 9 and then 4. You cannot do a partition this way. This one, this is not valid. I already explained it because this is the maximum minus minimum is larger than k. This is not valid. It's only one partition, and our prefix will become what? 3. This will be 3. Okay, let's move forward. Let's try to move forward. And then we go to our 1 wala logic. We come here. J is still 1. Try to remember that. Now, we'll insert 1 here. Does the mini minus maximum logic satisfy? Yes, it does. There's no need to remove anything. J will remain 1 itself. dp will be what? Prefix of whatever last we have computed minus prefix of 0. Because J minus 1 till J is satisfied. So 2 minus 0, that is 3, minus 0, 1, 2. There, number of ways turns out to be 2. This will be 2. And here, if we calculate, it becomes what? 5. So if we got 3, it would be 5, it would be 0. Cool. Let's try to move forward. Let's try to move forward. Now it will be 4, 1. This will be already 4, 1. Now let's try to move to 3. Okay. Still it is satisfying. Minimum is 1, maximum is 4. Still it is satisfying. There is no need to remove from the set, right? Because still our J is satisfying our logic. There's no problem in removing that. Set will help us to calculate the maximum minus minimum. Actually, we are calculating the subarray itself, right? So there's no remove to remove. J still remains 1. And now we will calculate our dp of, you can say, 0, 1, 2, 3, 4 equals to prefix of 3 minus prefix of 0 of 0, which is equals to what? 5 minus this will be 4. Number of ways will be 4, right? We're trying to calculate from the prefix part, right? This will be 4 and this will be what? 9. So this will become 9. 9. Okay. Now what we need to calculate? Let's try to do that. This becomes 4. And last part we need to calculate now, this 7. Now see, 4, 1. Also we have to insert 3. I forgot to insert 3 also. So we have 4, 1, 3 until now. And now we have to insert 7 also. So it will become like 7, right? It will become like 7. Now try to understand. See, mini is this, maxi is this. So we have to start removing from the left. We have to increase J. J becomes 2. We have to remove what? J at 4 we have to remove. So firstly we remove 4. See, we have to remove the contiguous order. So 4 we have removed. Okay, no problem. Now what we have to do? Is it still satisfying? No, it's not satisfying. We have to remove 1 also. Right? This we removed. Now our J becomes what? J becomes 2 and then J becomes 3. That is the idea. Now J 3 is still satisfying our condition. Means till 3, there's no problem, right? I hope you're getting it. 7 minus 3 satisfying our logic. So dp of 5, or you can say, yeah, dp of 5 equals to what? Prefix of 4 minus prefix of now. Understand that 2. Right? Prefix of 4 minus prefix of 2, because J minus 1 you have to do. This is what? 9 minus, or you can say 3, which is equals to 6 here. You can calculate it, 15. But we just need the 6, and finally the 6 is the answer. So I hope you understood it, how we maintain it, how we removed it, and continuously keep removing it. And yeah, let's move to the code part. So yeah, so what I was saying was, see, this is the actual code of implementation. So it's very simple. You don't need to do nothing much. It's like maintain a dp vector and a prefix vector. Now I already explained you that we have to make a 1 base indexing, not 0 base indexing, right? We'll make the things clear. And I will maintain a set also, right? We'll insert every element, current element until now what we have inserted, we'll insert it. And then what we'll do, this is very, very important, that we will keep only those elements which will satisfy our constraint. Satisfy our constraint means that the maxi minus mini logic should be less than equals to k. So if our maxi minus mini is greater than k, we'll keep removing the element. What we are doing, we are pushing J towards the right side. Pushing J towards the right side. Because we want the minimum J that should satisfy the condition. But if it is not satisfying, we have to remove it, right? So we are removing it and we're incrementing it to J plus plus. Firstly remove it, then increment the J. Then what we are doing, that's we found out now the J is a valid J. It's a valid J. But before J, till J minus 1, this is not in our control. Means like it is not in our answer. That means what? We'll calculate dp of I plus 1 from prefix of I minus prefix of J minus 1, because J is valid, K is valid, J minus 1 is not valid. So till J minus 1 will remove it from prefix of I and we'll take them out. And if this is the edge case handling, like if J is itself 0, means we don't need to remove any J. That's why it will directly make prefix of I itself. We don't need to remove anything. Otherwise also, and then how to maintain the prefix part? We just prefix of I plus 1 equals to prefix of I plus dp of I1. The current dp of I1 plus 1 we calculated, and the previous prefix, that is the idea. Very, very important. We're calculating dp of I plus 1 from the previous prefix we have computed until now minus the J.
Okay, right? Of course, this part, if we know what this point is for every...
I don't quite probably understand the solution for that one. But let's see.
The starting point, then this is, I wouldn't say it's easy. If we change the color, say this one, sum of sum, I'm trying to go back. You go to the sum of say. So I mean, oh wait, it doesn't work. No, oh yeah, because this is index. Whoops. I would have to guess, but now of course we have to try to do it faster, right? Because this is just not going to be fast enough, as we established, right? So So then now, I guess the way that I would think about it, right, is that I'm trying to bring up my drawing thing real quick. Oh, I still watch while I'm doing this. Okay, right, and then the idea here is that okay, so we have a DP array, right? Oops. Okay, we have a DP array, right? I wish I could draw better than this, but I'm using my fingers. Whatever. Our DP is that what's the answer? And then the idea here, the way that we wrote our DP is that what's the answer to this one, right? Oh, jeez, this is so hard. What's the answer to this one? Well, the answer to this one is equal to the sum. If you kind of look at the code real quick, right? It's equal to sum. I'm trying to bring it back. Equal to the sum of say, I'm changing the color. Say this one, this one, this one, dot dot dot, all the way to some point in which it cannot reach, right? Because then now the spread is too much. Okay, right? Of course, this part, if we know what this point is for every starting point, then this is, I wouldn't say it's easy. How is this a medium? Wow. Am I going nuts? I'm trying to.
Yeah, this is not a medium problem. This is a hard problem.
I mean, what? I mean, I know I could. I mean, I'm doing it. It's not difficult for me, but it just doesn't feel like a medium, which is kind of nuts. But in any case, yeah, the way that you can think about it, right, is just by well, the way that you would do it is just calculate backwards. I mean, right, calculate backwards, and then now when you calculate backwards, then now you have prefix sums, right? Or you have, I guess in this case it's a suffix sum, but you have the idea is that you just have a prefix sum, a data structure that's similar to prefix sum, so that you can enter this in O of 1, right? So if that does that make sense to you? My apologies is first, but that's because it's a very advanced, maybe not very advanced anymore, but still not a beginner or even intermediate concept. I would say this is an advanced idea, an advanced DP. But in any case, once you visualize it like this, though, I have it on screen. Okay, just want to make sure. Then now you can do this to the O of 1, and if you do this O of 1, then you're Gucci, right? However, the thing that I said was that that's only if you know what the endpoint is for each item, right? So then now, like for each beginning index, we have to find how far to extend, right? And then now, how's it already 10 p.m.? And then now the next question is, how do we figure this part, right? Well, you probably could do it with sliding window, if I had to guess. Because then now, yeah, I guess that makes sense, right? Because then now you start with, here you go as far as you can, right? Change the colors again. So you start with the first one, you go as far as you can, dot, dot, dot. And then now the next cell is probably just going to, is equal to you subtracting the first cell and then also try to go as far as you can to the right, right? So, okay. So I think that's it. I think we have all the components we need for this problem, even though it's a ridiculous problem for a medium. I'm kind of shocked that this is a medium. I mean, like, I don't know. I mean, yeah, no, I don't know. It's just hard. I think that's the idea that I would say. I mean, it's not like, I mean, I'm doing it. It's not impossibly hard. It is just not a medium, I don't think. I think if you label this as hard, I would not, like, I'll be like, okay, that makes sense. Okay, so then now we have to do the sliding window to calculate how far to extend, right? Yeah. So maybe I have a left 0, 0 for right in range of n. This is how I write it. I don't know how that right now. And then we have to kind of store, let's go like reach. Yeah, where we are. And then now you're trying to get the max and the min of a window, so we can just use a sorted list. Yeah. Right. Add num sub right. So then SL of num sub SL dot add num sub right. Right. And then now increment by 1, but before that we remove num sub left. It's sort of no, it's not. Oops, fine. So I mean, this is fine, but I think this is like a little bit annoying because because from this we can get from the right side we get the left side, but actually I want the other thing, right? I don't know. Maybe I'm just not thinking today. But when the left, okay, so fine, right? So then now for left in range of n, and then now right is equal to 0, right? So then while so okay, so now we want to say while right is less than or equal to left, we just add it in. So then the right is exclusive, and this is why you have invariance and understand it. And now right is inclusive, or exclusive, sorry, exclusive. Minus SL of 0,
What is this?
Is the way that Unicode right? So then now, how are we doing it, right? So then now, instead of using this for loop, we go, okay, well, we want total is equal to the sum. Fix sum thing, but it's going to be timeout. You actually have to not cache it.
You know what? I'll just wait for code story with Mike's video. That's that's what I can do as of now, because this problem is actually difficult. I think he can explain in a better way. But let's see the solution at least.
Hello everyone, I'm Paul and today we're solving problem 3578.
Dude, what? I thought he is Indian. No.
Count partitions with maximum difference at most k. The difficulty here is medium, but this is actually very tricky, or at least it was for me, so next we will go step by step. We are given an integer array nums and an integer k, so let's say that this is nums and k is 0. And we need to partition nums into one or more subarrays such that the difference between the maximum and the minimum element in each subarray is at most k. And we need to return the total number of partitions under this condition, modulo 10 to the power of 9 plus 7, because the answer may be too large. So if we are given this array and k is 0, we can partition this array like this. And here the maximum and the minimum elements is 3, and the difference between 3 and 3 is 0. And given that 0 is equal to k, and we are looking for a difference that's at most k, this is valid. So this is also valid, and this is also valid. To learn the total number of partitions under this condition, modulo 10 to the power of 9 plus 7, because the answer may be too large. So if we are given this array and k is 0, we can partition this array like this. And here the maximum and the minimum elements is 3. And the difference between 3 and 3 is 0. And given that 0 is equal to k, and we are looking for a difference that's at most k, this is valid. Partition, and here the minimum and maximum elements are 3 and 3. And the difference between these two is 0, and 0 is equal to k, so this is valid. And here we only have one element, so we know that this is valid. This partition is valid, so we add 1 to the result, and this is 2. And these are the only two valid partitions, so we return 2. We can't take this partition because the difference between the elements in this array is 4 minus 3, meaning 1, and 1 is greater than 0, so this is not a valid partition. Let's start small here. Let's say that we have an empty array. How many valid partitions do we have here? Well, we only have 1.
Dude, I don't understand what this means.
One element. So let's say that we don't have this. Well, remember that if we only have one element, the difference between 9 and 9 is 0. And this will always be smaller or equal to k, so this will always be a valid partition. And this is the only valid partition with one element. So when we take one element, the result is 1. Now, what if we take these two elements? So we don't have this. How many valid partitions do we have here? Well, we know that the maximum value is 9, and the minimum value here is 4. And 9 minus 4 is 5. And given that 5 is greater than k, this is not a valid partition. Now, we can split this in two, and we know that this is a valid partition because here we have only one element, and here we have only one element also. So when we have two elements, we have only one possible valid partition. Now, what if we take 3 elements now? How many valid partitions do we have here? Well, we can take an element or valid partition. Now, how many valid partitions do we have here? Well, we only have 1. So when the array is empty, we have 1 valid partition. Now, what if we...
How do I have one valid partition if it's empty? We need to check for non-empty continuous segments, right?
We take only one element. So let's say that we don't have this. Well, remember that if we only have one element, the difference between 9 and 9 is 0. And this will always be smaller or equal to k, so this will always be a valid partition. And this is the only valid partition with one element. So when we take one element, the result is 1. Now, what if we take these two elements? So we don't have this. How many valid partitions do we have here? We know that this is a valid partition because here we have only one element and here we have only one element also. So when we have two elements, we have only one possible valid partition. Now, what if we take three elements now? How many valid partitions do we have here? Well, we can take this partition because here the difference between 4 and 1 is 3 and 3 is smaller than 4, so this is valid, and here we only have one element, so this is valid. And we can take this partition also because here we have three different subarrays with one element each, and we know that subarrays with one element are valid, so this is another valid partition. And that's it. We can't take this partition because the difference between these two is 5 and 5 is greater than k, so these are the only two partitions that we can take, so here we put 2. Now this is where it becomes interesting. What's the length of the largest subarray that we can take with this number as the right endpoint? Well, we can take this window, and here the maximum number is 4, the minimum number is 1, the difference is 3, and 3 is smaller than k, so this is valid. Now the main observation here is that if this is a valid subarray, this is also a valid subarray, and this is also a valid subarray, so here we have 3 valid subarrays. And maybe you're wondering why. The maximum element in this array is 4, and the minimum element is 1. This difference is 3. So if we shrink this array, if we remove this element now, well, given that now we have these two elements, and they were part of this array, we know that
There's a formula to calculate this. I believe it's sum of to that n number. Like if n here so is 3, like the size of the window is 3. So what will be the number of partitions? Now, the number of partitions will be 1 plus 2 plus 3, which is 6. But I think I am wrong. 1. The individual partitions is 1, 2, 3, 4, and 1, which is fourth partition. 1 and 3, which is the fifth partition, and 4, 1, 3, which is the sixth partition. So I am right.
the largest element here will never
It's just a small trick that you can use to find the number of partitions, a number of subarrays.
exceed 4, and the minimum element will never be smaller than 1. So we will never have a greater difference than 3. That's why this is also valid. And if we remove this, well, this of course is also valid. So if we take a partition where this is a subarray, we can combine the total number of partitions that we can take with the previous elements from 0. How many partitions do we have in this range? Well, we have this information. We have it right here. Now, if we take this subarray instead, how many partitions range? Well, that we can take with the previous element. So if we take a partition where this is a subarray, we can combine the total number of partitions that we can take with the previous elements from 0. How many partitions do we have in this range? Well, we have this information. We have it right here. Now, if we take this subarray instead, how many partitions can we take with this element? Well, we have this information here. And
Okay, that's why he was summing up from valid like j to I or I minus 1, basically I, the prefix sum. Okay, I understand. Right now, I can understand it better.
if we take this valid subarray, how many partitions do we have with this element? Well, we have this information right here. So we can add these three elements, 1 plus 1 plus 2 is 4, and this is the value for this position. And in case you didn't notice, this is a DP array. We are storing in every I plus 1 the number of partitions in the range from 0 to I. And at every step, we are keeping track of the largest possible valid window, and we are adding the corresponding previous results for each position in the window to the next position in our DP array. Now here we added 3 elements, and that's how we got 4. The thing is that we can have up to 5 times 10 to the power of 4 elements, and this is a lot. We need to find an efficient way to get sums of subarrays in big O of 1 time complexity. And for this, we can use something called prefix sum. Another problem is that we need to check the size of the largest valid window at every step efficiently. And for this, we can use a sort list. So let's see how to use prefix sum, and then I will show you the full approach. Let's say that we have
Okay. That's why he stole a sorted list, because we can find the min and max value instantly. Okay. Okay. I think I'm understanding it better now. Let's see.
And for this, we can use a sort list. So let's see how to use prefix sum, and then I will show you the full approach. Let's say that we have an array of this same size, and we are storing here the accumulated sum up to every point. So first we have a 9, then 9 plus 4 is 13, then we have 14, then 14. plus 3 is 17, and 17 plus 7 is 24. And now let's say that we're trying to get the sum of this subarray. Well, we can take the right bound and subtract left bound minus 1. So we take the sum of every element up to this point, 24, and subtract the sum of every element up to the left bound minus 1, meaning we subtract 14. And the result here is 10. This means that the sum of the elements in this subarray is 10. And just to be clear, we are trying to get the sum of these two elements. So we take the sum of every element here up to the right bound, meaning we take the sum of all of these, and subtract the sum of all of this, meaning the sum of every element up to the left bound
24
minus 1.
minus 14.
And this is how we get this subarray. So with this in mind, now let's see the full approach. We have a DP array of size n plus 1, where the first element corresponds to the amount of valid partitions of an
Yes, that is the 0th index, which means that there are no elements in the subarray. So the number of partitions is valid, which is 1. Because an empty set would mean that there are 0 elements. So the max and min will be 0, will be null, not 0. Technically, it will be null. Okay. So number of partitions there is 1.
empty array. Remember that this is 1. We have an empty sorted list, and we are using this to keep track of the numbers in within the valid window, the current valid window.
Wait, what?
We have an empty sorted list, and we are using this to keep track of the numbers in within the valid window, the current valid window at every point. And instead of using a prefix sum array, we are using an integer. This is initially 1 because this is
Okay, so what data structure can we use so that it is in sorted order? The numbers are stored in sorted order, and the operations for remove and peak, or say the value, is O of 1. It is we can use in Java we can use a tree sec, right? Because tree sec will automatically just sort the values in ascending order, and then we just need to. But how can we find the okay, in a set, how, how can we access that element? Because we don't have the get function, but we can peek. Yeah, we can peek. Let's check in. Oh my god! In a tree set, let's fix the capitalization. In Java, how can we access the elements? Elements, yeah. This is this. Nah, but I wonder. Oh, so we have this function dot first and dot last. Next, lower. Oh wow. Okay, this is pretty good. No, no, no. Jason. Okay, so we can just write call this function dot first and dot last. So if I use a normal set, how can I access the smallest and the largest element in O of 1 operation? Let's see. Let's see for this. Let's check for O of 1 condition later. In a normal set means hash set. Okay. And now direct way to access this is this. There are no first and last methods. does not maintain order. Yes. So it's better to obviously use a tree set here.
Is 1. Here we are doing a prefix sum of this DP array. We have left and right pointers. We are using right to iterate every index, and we are using left to keep track of the current window. So with left and the sorted list, we are keeping track of the current window efficiently. You will see how this works in a few seconds. So first we have a 9. We need to add this to our window. So here we have a 9 now. And now we're checking if the difference between the maximum and the minimum element in this sorted list is greater than k, because if it is, we need to remove elements from the window. And the difference between 9 and 9 is 0. We know that this will never be greater than k. So we are ready to continue. Now we can say that dp at I plus 1, meaning here, remember that this array is left shifted, so from this index I plus 1 is here. Here we need to store the current accumulated number, this number. So here we put
The dp is right shifted,
the 1.
not left shifted, I guess.
And the new accumulated number is this plus the new number. 1 plus 1 is 2. So here we put the 1. And the new plus 1, meaning here, remember that this array is left shifted, so from this index I plus 1 is here. Here we need to store the current accumulated number, this number. So here we put the 1. And the new accumulated number is this plus the new number. 1 plus 1 is 2. Remember that this number corresponds to the amount of valid partitions if we only had an array with number 9. So this is 1. Now we are here, so we need to add 4 to our sorted list. And remember that this will automatically sort these elements. So this will be the correct order. And now we can get the difference between the maximum and the minimum elements here in big O of 1 time complexity. How can we do this? Well, we can take the last element and subtract the first element in the list. And the difference between these two is 5. And given that 5 is greater than k, we need to remove elements from our window. And this is why we have a left pointer. Now we remove from this list nums at left. So we remove 9. And given that we are removing this, we can also remove the corresponding result from our prefix sum. So we can go to our dp at left, meaning here, and subtract this from the prefix sum. 2 minus 1 is 1. So now we can add this from the prefix sum. D at left, meaning here, we're removing this left. So now we remove, and this is why we have a left pointer. Now we remove from this list nums at left. So we remove 9. And given that we are removing this, we can also remove the corresponding result from our prefix sum. So we can go to our dp at left, meaning here, and subtract this from the prefix sum. 2 minus 1 is 1. So now we can update left, and given that now the difference between the maximum and the minimum elements in this sorted list is 0, and 0 is smaller than k, we are ready to continue. So now dp at right plus 1, meaning here, is equal to the current accumulated number. This is 1. And the new accumulated number is this plus the new number, meaning 2. Now we update right, and first we need to add this to our window. So here we put the 1, and the new sorting will be the following. And now the difference between the maximum and the minimum elements here is 3. And given that 3 is smaller than k, we are good to go. We can add to this position the current accumulated number, so this is 2, and here we need to add the new number, because here we are storing accumulated numbers at every step, so the new prefix sum is 4. Now we are here, so we add 3 to our sorted list, and the difference between the maximum and the minimum elements here is still 3, and 3 is smaller than k, so we can add these to the current position plus 1, meaning here we put the 4, and this is now 4 plus the new number, meaning 8. So now the right pointer is here. We need to add 7 to our sorted list. And now the difference between the largest and the smallest
What was accumulated?
elements is 6. And given that this is greater than k, we need to remove elements. So we go to nums at left.
You know what, we'll solve this problem later. Because this is a daily problem and definitely I will solve this problem, but not right now. So, spend so much time. 1 hour 15 minutes. Okay, I need to charge my laptop first. Oof. Mm. Mm. Okay, let's solve this problem first. Problem 3759. Count elements with at least k greater values. It's a medium problem. It's rated 1372. I had tried this problem earlier, but I think I didn't get the right solution. Let's see, let's solve the problem. Hmm. You are given an integer array nums of length n and an integer k. An element in nums is said to be qualified if there exists at least k elements in the array that are strictly greater than it. Mm, Re- Return an integer denoting the total number of qualified elements. Is my screen properly visible? Oh, mm, Okay. Ah. Hmm. There are at least k elements in the array that are strictly greater than that. Hmm. Okay. What are the constraints? 10 to the power of 5. So I believe you cannot use array. Let's check. Oh my God. Can I use an array for nums dot length equal to 10 power 5? Hmm. Nums is said to be qualified. Integer denoting the total number of false statements. Okay. Isn't it better to use a tree hash map or or a tree map instead of this? I will use a tree map. Let's see. Uh, how to store, huh, how to store elements in a tree map in reversed order, or that is descending order. Let's see. How can we do that? Mhm. Just collections dot reverse order. Perfect. Okay. So instead of doing this, just store in a tree map integer comma wait. The nums.I is 10 power 9. So let's use long. Why is there int here? Wow. The frequency cannot be that big. Let's use an integer map. Sorry, frequency equal to new tree map of collections dot reverse order. Collections. Is it collections? Collections. Okay. Hmm. Just iterate over the array and count the frequency, right? So frequency dot put nums of I frequency dot get or default this will be nums of I or 0 plus 1. Now that we have the frequency, we just check that the largest numbers, the largest numbers frequency, whether or not it's greater than, wait, an element is saying that if there exists at least k elements in that array that are strictly greater than it. At least k elements. Okay. At least k elements that are strictly greater than that. So why are we counting the frequency as well? We just store it in a hash set, in a tree set, in a reverse order, and then just hmm, and then just iterate over the array k times, hmm, k times. So we'll get a count of uh at most, at least, right? So yeah, I get it. So just use a preset. Does preset require? Ah, yeah, of course. This long set preset. Yeah. Then run this loop int I equal to 0. I is less than k. Yeah, this is the condition that I was worried about, but I don't have to be worried right now because k will always be less than n. Okay, perfect. I plus plus. Okay. Now we just if no plus plus. We just see if set dot what is this? Oh wait, we need to first initialize our set as well, right? So for int I equal to 0, I is less than n, I plus plus, just set dot add, I believe it's add nums of I. Uh, set dot add syntax. Let's see. Hmm. Reverse order. Yeah, okay. This makes sense. I take through this k times. But yeah, but what if iterate over this set dot size times, and if k minus minus, no, if k equal to 0, just break. Else, no, else just decrement the value of k, right? At the end, we just check if k equal to 0, then we do n minus k, otherwise we return 0. Because if this condition satisfies, it means that there are n minus k elements, there are n minus k elements that are strictly greater than k elements in the array. Okay, and if not, if k is not equal to 0, becomes equal to 0, it means that there are no such elements. Yeah, this makes sense. Let's just store it in a variable so that this set.size function is not called every single time. Let's give a let's first run. Okay. Expected business. I'm off by 1, but let's see why. We need 1. K is 1. So we need to find uh it, we need to find the numbers which are greater, at least k, at least k elements in the array are strictly greater. These k elements. Hmm. At least k elements are strictly greater. Yeah, so at least k, no? So this should be -1. Let's check for couple. Let's first run this. It will work for this, obviously. Yeah, but let's check a few other examples. Let's see. Okay, so it works. Okay, what if there is only a single number and k equal to 0? So 1 minus 1. Oh, this is a special case, right? Let's just handle it separately. Because if we have this with n equal to 1, just return 1. What if we have only two numbers? And what if this number was even bigger? Hopefully this works. Let's see. Yeah, this fails. For k equal to 0. Mhm. Okay. So, okay, so k equal to 0 is the problem. So if k equal to 0, how many numbers are greater than this? So it will be equal to n. This should work. Yeah. But now, what if this k equal to, what if k equal to 1? Oh, let's see. So k equal to 0 was a special case. Hmm, so this, well, the solution as all the test cases. Let's see. What do you mean by flaw? Um, let's copy this. Let's see. equal to 2. Don't have spaces in between. K equal to 2. My answer is 3, but actual answer is 2. 4 minus, there are two elements that are greater. What? Oh. Fix the errors. Let's see what are the errors. Sort in ascending. We could have done that. Yeah. Greater. What? No, this is probably wrong. This is wrong. What? Nope. No short. This is correct. Let's see. Okay.
Hello everyone, welcome back to my YouTube channel. So today I'm going to solve question number 1 of weekly contest 478. Count elements with at least an element in nums is said to be qualified if there exist at least k elements in the array that are strictly greater than it. Right?
Wait. What if k equal to 0, return n? We don't even need this. Let's just sort the array first. Arrays dot sort nums. Right now, for int I equal to n minus 1, I is greater than equal to 0. I minus minus. Now just check if at any point if k equal to 0, just break. No, we should do this here. No, we should do this here. So this will handle this case as well. But let's see. If nums of I is greater than, so this should be this, is greater than nums of I minus 1, the value of k will decrease because this is sorted in ascending order. So this index, if this is greater, strictly greater than the previous element, then we found one element that is greater, right? Now, if k is equal to 0, just return n minus k. Now, n minus k should work. I don't understand why this is n minus k minus 1. If here n is 3, k is 1. Okay, oh my god. Okay. Wait. Boom. Let's use another variable, store the value of k in another variable. I get it. What was going wrong there? What should we name it? And check. Let's just name it check. So this condition is necessary if k equal to 0. Wait, let's see. If now return if check equal to 0, then just simply return n minus k, else it will be 0. This makes sense. Let's run it. Okay, this will pass all the test cases, and I'm pretty confident in it. What I was doing, I, where I was going wrong was I was decrementing the value of k here, right? So what happened was here actual case values got decremented to 0, and we check if k equal to 0. This will be always true. I mean, if this is if k becomes equal to 0, so n minus k will always be equal to n only, because the value of k is 0. But we should have assigned it in a different variable. It's okay. This will pass all the test cases. What? Why? K is 2. No, wait. K is 2 for k equal to. So you need at least 2 elements. An element in nums is said to be qualified if the ret exists at least k elements in the array that are strictly greater than it. So we have 1 and 2 more elements should be strictly greater than this. This should be 0. Why is I don't get it. Why is this 2?
We have to return and if 3, right? So 2 elements are exist, at least k elements. At least k elements. It may be equal to k or greater than k, right? The number of elements, right? Number of elements should be greater than k, right? So here From this, we are good, right? One or more than one, that is fine, right? Here one, it is also valid, right? So we have to find out how many elements in nums, right, in which these elements are qualified if there exist at least k elements in the array that are strictly greater than it. Okay, so we have written an integer denoting the total number of qualified elements in num. So this is qualified, right? This is qualified, right? So output is 2. Clear? That's it. The elements 1 and 2 each have at least k is equal to 1 element there. I am here at 2 this, right? I am, let's make, and so now the last, so here I'm total number of can subside. So say this is can do its last index in the sorted
Okay, this was my initial uh code that I was going to do, but let's see.
array, right? So here last index dot put nums of I value and here index. Okay, this is
N minus 1 minus last.
clear, right? Then you have to calculate the count. So let's see how we are calculating the count here. Okay, so first element, let's say 0. How I'm calculating? So here, if you see, I'm doing n minus 1. N minus 1 means 9 minus 1 minus 0. So here I'm getting 8, right? So there are many ways, right? So you can write it like this. Right? Or you can also write it like showing n minus last minus. You can, if that's if you see plus of,
Let's ask Gemini. Gemini. Oh, good. 8, 4. What else? My 4, 6. Mm-hmm. This is true. At this next, at least k greater values if and only if it is smaller than k plus 1 element. K plus 1 largest element. This. Mm-hmm. Not index. At least k greater values. But what if the numbers are repeating? N minus k minus 1. This is 2. 1 has greater values. We just need to find if now just qualify if there are at least k elements in the array that are strictly greater than it. At least k elements. So we just check if the smallest element there are at least we have the smallest element, right? We just check if there are k elements present in the array or not. Return an integer generating to qualified.
And so overall, actually, the time compressor is going to be this one, right? That's it, right? N minus I was.
So you just mentioned that you want to learn Python. So do not learn Python.
Hey everyone, good morning. Least array nums are element that element. No approach, some better approach with better time complexity. So let's try to understand. This is one right, at least two people. Okay, so let's say they are standing in the at least is greater than one. Okay, so your height is greater than two. Okay. Similarly, for one, there are four people after one, so there is at least two people. There are at least two people whose height is greater than 1. Okay, so your answer will be 3 because you need to return the count of people among these people. Okay, so what we are trying to understand from here is that, let's say, like they are standing like this. After each number, only then that will take to your threshold will become this one. Or you can say now 2, 3 is it off, right? So this minus 2, your threshold will say 0, 1, 2, 3, 4, right? This will be your threshold in this case. Let me just erase 3 element will be your threshold, and this is itself the second element, right? This is itself the second element, so this is also not a qualified element, but this will be your threshold element. So any values less than this element will be your considered as your qualified element, right? Okay, but let's say you will now say that this was the case of distinct elements, but in our answer, in our use case, there can be same values as well. So what will happen to them? Okay, so let's see with that as well. So let's say if you have been given with something like this, okay, 5 5 5 6 6, and let's say your k is 1. Okay, so you need to get the total number of people who for which there should exist at least one people whose height is greater than them. Okay, so from our approach, in let's threshold will be 5 minus, so this will be your threshold. So any value 0 1 2 3 4, so this will be your threshold. So any value less than this will be considered as your qualified element. So now you can check for all the elements. Let's say 5 is less than 6, yes. 5 is less than 6, yes. 5 is less than 6, yes. So your answer will be 3 because 6 is not less than 6. So see here what I was mentioning, that there should exist at least k people after that element. Okay, so in this case, in the case when the similar height people can exist, so see, there is at least one people after 6, but still this can't be considered as a qualified element. That's why we are comparing it with the threshold and not with the index. Let's say we can't directly, because the elements, the value could be 3. Simply first sort your array, now then only you will increment your answer, right? Then only you will count that element as a threshold element. Okay, so let's see its code as well. Its code is quite similar as the pseudo code I have written. So we will first initialize over there and yeah, there is one edge case as well. Let's say if k is 0, then what you will do? If k is
Return
0,
an
then if you will So if your k is 0, then obviously you don't need to check any should the elements of your. You check if your value.
Okay, I understand this, but I'm still confused if, let's see, if there are repeated numbers here, okay, k is equals to 2, so the threshold will be n minus k, which is 3, the third index, n minus k minus 1, yeah, the second index, 0, 1, 2. So this is the threshold. So we need to find numbers which are strictly less than this. What if I had another number, say 6? So 6 minus 2 is 4, 4 minus 1 is 3. So 0, 1, 2, 3. There are at least n minus. Now, if this was 2, let's say 1, comma 2, comma 2, comma 2. We have 3, we have 5, we have 5, we have 6. So there are currently, wait, we need 6 elements. There are currently 6 elements, 6 and k equal to 2. So 6 minus 2, 6 minus 3 basically is 3. So it is here. So number of elements greater than this is only 1. And this is correct as well. This is a problem where you need to know ahead of time a couple of things. This is definitely not a constructive problem. So and dash or equal to n minus k minus 1. If k equal to 0, return n. I'll sort this. Imagine and threshold number is nums of I should just directly do this. Okay. Now just iterate and num and nums. If num is less than the threshold num, result is plus. Int result equal to 0. And at the end, just return result. Huh, what I did sort n minus k. The index will be, how is this n minus k? It should be n minus k minus 1. Yeah, n minus. Oh, minus k. Okay. Okay, so what this problem was, what this problem was basically just find number of elements that are uh number of elements that are smaller than k amount of elements, right? So we just find a pivot point after which the numbers will obviously be greater. So we just calculate the numbers which are less than that pivot point and then return the result. What I was doing was going from behind, right? I was just checking if whether or not there exists k elements that are greater. If there are k elements that are greater, it would obviously mean that there will be n minus k elements that will satisfy the condition. But what I forgot was n is the total length and n can contain and the of the nums array, and nums array can contain duplicate numbers. So what I should have done is instead of subtracting n minus k, I should have subtracted from the hash set's length minus k. So let's see. Let's do that. Let's try that solution as well. Hmm. Then there is LeetCode. I spent so much time in this single problem, it was not worth it. Shit. Let's see, can I get my hash set solution back? Okay. So instead of doing n minus 1, I just do length minus k, and this will be not minus 1. Let's see. Is it n minus? God. What k is 1? If the length is, oh, length of the hash. Let's just print this out. Print length plus, what is this? N plus k. See. Rubbish. Oof. Almost press command. Just return 14. Mm. Oh my god. Of course. Int check equal to k. Check equal to 0, then break. This is the wait a minute. Oh wait. Do we even need this? No, right? Arrays dot sort nums. This is this. But we do need, oh my god. We do need a set arrays dot sort. Yeah, collections dot reverse order. If nums of I is greater than nums of I plus 1. Check minus minus. Once it reaches 0, just break. Now, if length minus k minus 1, if check equal to 0, comparator takes the syntax in the comparator. Sort this one hell no. Dude, this is 3, this is 3, this is 8. So yeah. It's a little bit length minus. What the sorry. But there are this many unique elements in this. Let's just for in minus. Oh brother. Oh shit. Can I just directly bring this out? I can, right? No, I can. Good to know. Oh, okay. So we need at least one element. At least k greater values. So this needs to have only one element that is greater than it. So for one, we do have for one we have, for two we have, for three we have, for four we have 5, 7, 9, 34, 54, 56, 432, 457, 76. Hmm. Oh, we need to multiply the frequencies as well. That's why initially I was thinking of the hash map. Okay. So this should be n. So why did n minus k not work? Oh, it did work, but it failed for this. Let's see why. This. We have one, K equal to 2. So we need at least two greater elements, K greater values. At least K greater values. So for 1, we have, oh, no, for this one, we have a greater value. For this one, we have a, oh, okay. Okay, so this code actually makes sense now. I understand. Why we took that pivot. Yeah. Anyways, move this to the down. What is the folder? 37. Yeah. Get add, get submit. I spent way too much on this problem. Way too much time on this problem. Okay, push. I will pay back. So it's 137 as well. Just go to the washroom and I will be back. Okay, I am back. Let's solve some problems. Where is the website? There we go. I'll be sorting this by ascending order. Bi-weekly contest 125. Okay, let's solve this. Problem number 3066. 3066. This is a medium again. Okay. Close this, and let's go. Problem number 3066. Minimum operations to exceed threshold value part 2. Okay. You are given a zero-indexed integer array nums and integer k. You are allowed to perform some operation on nums where in a single operation you can select two smallest integers x and y from nums. Okay. Remove x and y from nums, insert minimum. Okay, so we have to perform this operation. Okay, at any position in the array. Okay, note that you can only apply the described operation if nums contains at least two elements. Nums will contain two elements. This can be large and k equal to this. Okay, what is k? What is k? Now that return the minimum number of operations needed so that all the elements of the array are greater than or equal to k. Okay, return needed so that all the elements of the array are greater than or equal to k. Conditions that all the elements of the array are greater than or equal to k. Okay, so our goal is to make these numbers which are small at least equal to k, and this is a minimum of single operation. Okay, I think we have to sort the array. Yes, we can sort the array here. Okay, the input is generated such that the answer always exists. That is after performing some operation, number of operations, all the elements will be greater than equal to k. Okay. What I am thinking of is to use a min heap, right? And just keep selecting the first two elements from the min heap and perform this operation, remove the two elements, perform this operation and insert again in the min heap. So I need to use a priority queue of this will be integer, right? PQ equal to new priority queue. Okay. Now here we just insert the values I equal less than 1 plus PQ dot add nums of r int n equal to nums dot length. Okay. Okay. Now I just want to see that how to access the first and second element in a priority queue, and also how to count the elements. Okay, let's see. Okay, so this is simple add. Okay, now to see the first element, oh, we should just remove two elements from it. Yeah. We should, because we anyways have to remove this element, right? So while priority queue is empty, basically if it's not empty, and priority queue dot peak, the element here is greater than or equal to k, we perform this operation. Now let's define this int operation equal to 0. Now if we enter this loop, just increment the operation, but first perform a couple of operations where int num1, or let's just say x equal to pq dot poll. Now what poll does is that if we suppose we have an empty priority queue, it will just return the value null. But our priority queue here will never become empty. Why? Because we initially check if our priority queue is empty or not. Now, int y equal to pq dot poll. Here we can face a problem, right? Why? Because here we check if priority queue is empty or not. If priority queue has a single element, it will return true that it is not empty. It will enter this loop and then assign that element into X. But now our priority queue is empty. So we check, no, we don't check. Basically, we write this condition pq dot poll. Why? Because now since our priority queue is empty, it will return a garbage value, but we don't want a garbage value. So instead of a garbage value, this will return null. But now, as far as I remember, int is a primitive data type. It cannot store null values. So we have to assign here integer. But in this problem, we don't need to assign this as integer because we'll never reach the condition where this will return null. Why? Because we have at least two elements in the array. So this will never return null. Okay. We have these two elements. We have removed these two elements. Where is this? Now just int int z equal to math dot min of x comma y into 2 plus math dot max of x comma y. Oh, now just add this value in the priority queue and we should be good. And then increment the value of operations, number of operations. Now just return the number of operations. This should work. It is returning 0. Okay, so it's not even entering this. K is 10. We select 1 and 3. Perform this operation. Let's just bring the values. Let's debug this code. Print, yeah, and then x plus y plus, oh wait, we don't do this. X plus y plus z. Do we never, oh my god, do we even enter this while loop? We never even enter this while loop. Why? I believe because this is empty, this doesn't, this didn't add the numbers or something like that. Why did the while loop never execute? Hmm. Oh wait, this is less than. Oh my god. This is less than. Okay. Okay. This should work. Yes. 1, 2, 4. Select 1 and 2. Perform the operation, we get 4. Then select the next smallest to be and 4. Perform the operation. There's 10. Now we in the array we currently have 10 comma 10 comma 11. Now 10 is basically bigger than or equal to 10. So we stop. Okay, this works. Let's just give a submit. I thought of this. Oh, oh my god. This is a no way. Runtime error. Okay, is this? Oh yeah, why do we even perform this operation? X will always be less than X will always be less than Y, obviously. What what is PQ dot offer? What is to insert an element in okay. Yeah. For this problem, why did my code fail? On this test case? Uh-huh. Too smallish. Mhm. Yeah, this should be long. Mhm. This is a mistake. I should have been careful to convert this to long. Yeah, this should work. Let's double check. Nice. Yeah, cool. Get hammered. Get hammered. Oh, get push. Okay. Mm, okay. I think I will take a break, eat some food, and will be back soon. Okay, I am back. Let's solve some problems. Yep. So we have solved this problem, right? Let's see. Oh, I've solved 240 problems. Nice. Okay, let's solve some more problems. Let's see. Mhm. We have solved this problem. Let's solve this problem. Number of ways to buy pens and pencils. Okay, to question number 2240. 240. Am I sharing my screen? Yes. Problem 2240. Number of ways to buy pens and pencils. Okay. You are given an integer total indicating the amount of money you have. Okay. You are also given two integers, cost 1 and cost 2, indicating the price of a pen and a pencil, respectively. You can send part or all of your money to buy multiple quantities or none of each kind of writing utensil. Return the number of distinct ways you can buy some number of pens and pencils. Okay, so we have this total is 20. Cost 1 is 10, cost 2 is 5. You need to output is 9. So there are 9 different ways. Okay. If you buy 0 pens, you can buy 0, 1, 2, 3, or 4 pencils. Hmm. Okay, that's a way. And if you buy one pen, you can buy these many pencils, 0, 1, or 2. If you buy two pens, you cannot buy any pencils. So the total number of ways is this is 1, 2, 3, 4 plus 4 plus 1, which is 5 plus 1 and oh no, what? This is 5, sorry. 1, 2, 3, 4, 5. Okay. Hmm. Then this is 1, 2, and 3. So this is 1, 2, 3, 4, and 5. Oh, yeah, yeah, yeah. You can buy 0, comma 0, 0, comma 1, 0, comma 2, 0, comma 3, and 0, comma 4. Okay. So that's how this is 5. And then 1, comma 0, 1, comma 1, 1, comma 2. So it is 3. And then only one way. Hmm. Okay. The price for the pens is this. The price of both pens and pencils are 10, which cost more than total. So you cannot buy any writing pencils. Therefore there is only one way, buy 0 pens and 0 pencils. Okay, this is a good edge case to handle. Okay, so we'll buy, this is one. Okay. Hmm. Okay, let's see. We have total cost 1 and cost 2. Let's calculate the base. Okay, it can be long. Base equal to 0. Let's see. There can be only only 20. Okay, 20 divided by 10. So there can be only two cases. Oh no, rather three cases, because we cannot buy anything. So there can be three cases. Hmm. Which is not buy a pen, buy one pen, and buy two pen. If we divide 20 by 10, right? So we'll run a loop from 0 to 2, right? And then calculate the number of ways. Now, we don't know if cost 1 will be greater every single time or no. So it's just a simple check, we can do that. And also, we need to check whether or not the minimum amount, whether or not the minimum amount is less than the total amount we have on AutoPay. So there are a couple of checks we need to do. But let's first say int first, let's first see if cost 1 is less than cost 2, just swap cost 1 and equal to cost 1. This is cost 2 equal to cost 1. For when pi equal to 0, I less than total divide by cost 1 plus plus. Let's see. The cost cannot be equal to 0. That's good. Mhm. The plus plus. What do we do here? Now, if I equal to 0, it means that let's just total divide by okay, we just need to decide the name. What do we call this? N. Say N. Now, this is basically I is a basically cost 1. Like if you number of pens we are buying basically. So if you buy 0 pens, yeah. If but this needs to be divisible as well. Hmm. Ways plus equal to total divide by 5. Oh, not this 5. Cost 2. Right? Then if we have 1 divided by 4. No, 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 no. If this is 0, we take all the cost. If this is 1, when is equal to 1, then we decrement the value. This should be equal to. So, store this in another variable and C2. Let's call this C1, C2 equal to this, and then just do C2 minus I. Like we need to check for this as well, but let's see. Let's run this. This is the number of ways, and also convert this to long. Return base. This should work. Oh, why is it taking so long? Oh no. This work. I don't know why my net is so slow. I'm refreshing the page currently. What is this? Hopefully this works. Let's see. I am not sure if I should divide this or should just multiply this by this, because C1 is basically I, right? Let's run this code first. Hopefully this runs. I know I have not handled this case yet, but let's see. Please run. Why is what? Is my Wi-Fi slow or is LeetCode down? Is this working? 0 when equal to 1. Then we decrement the value. The stream's working fine. Please run. Yeah, okay, so this is correct. But let's see for this. If total if total is less than if total is less than the minimum cost we have, then return 1, right? Hmm. If total is less than cost 2, which is the minimum as of now, just return 1. But I'm not confident enough that this will pass all the test cases. Why is this? Okay. Will this code pass all spaces? Incorrect swap. Oh my. Oh my. Okay. Is not the number of valid choices. Won't be negative. Yeah. Total minus I times into cost 1. And then remain. Yeah, this works fine as well. And plus 1 because the no buying nothing from each of those case. I mean this 0 case. 0. This works as well, yes. Instead of writing or creating a separate variable, just write it here. Like if suppose this is pen, then this is pens into, just multiply this here. As I said earlier, should be less than equal to total. But they didn't even check. Oh yeah, no need to do this as well. Right. So we have a remaining value or a remaining cost, which will be total minus pence into cost 1, and then just calculate the ways, which will be remaining divided by cost 2 plus 1, then just return. Should I type past it too long? It's better to type past it. Why is it not running? Then it's what? Nice. Okay, let's solve another problem. Find smallest common element in all rows. This was a Q3. Oh, bi-weekly contest 9. Okay. Oh, wait. What was the problem number? 1198. 1198. Oh, this is a premium problem. Never mind. Let's just solve minimum rectangles to cover. Oh, Minimum rectangles to cover points. Okay, let's see. 3, 1, 1, 1. 3, 1, 1, 1. No. I hate these types of problems. You are given a two-day integer array points, where points is xi comma yi. You are also given an integer w. Your task is to cover all the given points with rectangles. Uh, each rectangle has its lower like this. Mm, okay. Yeah, nah. This is a annoying problem. Yes, this is true. A point is considered covered by a rectangle if it lies within or on the boundary. Okay, this is problem number 311, minimum rectangles to cover points. You are given a two-day integer array points where points I is this. You are also given an integer w. Your task is to cover all the given points with rectangles. Each rectangle has its lower end at some point. This makes sense. Okay, and upper end at some point. Okay. Where this. And the condition is this is this. Upper end is at x2 comma y2. Okay. If it lies within or on the boundary of the rectangle, then return an integer knowing the minimum number of rectangles needed so that each point is covered by at least one rectangle. Okay. So we have some points here. 2 comma 1. So this, okay, this is 2, 1 comma 0, 1 comma 4, 1 comma 8, What is the value of W? W is 1. Okay. So what I think is the distance Y doesn't even matter, right? So just sort this on the basis of x-axis and then just check if just what are the constraints. Are the constraints low? Yeah, 10 power 5, which is fine. Okay. Hmm. Just okay, this looks pretty easy. Let's see. Int rect equal to currently 0. Let's see, we need to sort this. Int oh, this goes up here. R equal to points dot length. Int C equal to points of 0 dot length dot length. Okay. Now we just need to sort this array, right? On the basis of x-axis. See, the y point doesn't even matter because the rectangle can be as high as possible. It's just that we need to make sure that x2 minus x1 is within the limits, which is less than equal to w. This okay, so I'll just what I'll do is just store it in an array, right, of size equal to this. No, R size equal to R number of rows. Yes. So we'll create an array of size R. It's 10 to the power 5 now, so sorting will go. It's fine. Arrays dot sort ARR. But first let's copy these values. Okay. Is less than R, I plus plus. I just need to insert the first value, right? Points of I, and this should be 0. Makes sense. We return rect. Okay. Now for we have a sorted array now. Let's see for int I equal to 0, I less than n I plus I plus plus. If what do you call this array of I, this will be n minus 1. If array of I plus 1 minus this, if this is less than equal to w, Now, if this becomes greater than W, just do rect plus plus, which means that we need to form a new rectangle. At that point, start a new rectangle, right? And then just return rectangle. Let's see. Of course. What? 0, 1. Oh, wait. Oh, wait. We need to use the sliding window technique. Wait a minute. While I is less than equal to j, what is I, what is j? Int I equal to 0, j equal to 1. Now, j equal to, yeah, 1. Oh, no, let's keep it 0 because W can be 0 as well, right? Yeah. So, if nums of I, sorry, j minus nums of I is greater than W, then just do ref plus plus. Let's just get this and save it in a different variable. That would be better. If def equal is greater than W, we need to create a new array, a new rectangle, but we also need to increase while, what do you call this, array of I while I is less than n, that is R, and array of I, oh no, is less than equal to say, and array of I is array of j minus array of I is greater than W. As soon as this becomes less than W, we stop I plus plus, and then here we do a J plus plus. We move on to the next element. What? Oh my god. Sorry. Array. What's it? What? Out of bounds. Oh wait, yeah, and j is less than r. We need to check this as well, of course. This is kind of offensive, which is not good. Wait, if we find that this is different, the difference is greater than w, just make I equal to j, because we start a new rectangle from there. Yeah, and this will go in else. Mhm. Is this off by 1? This is off by 1. Why though? Oh yeah, initially we'll have one rectangle at least, right? Because at 0 commas, yeah. If we find that this is different, we increment rectangle, which is will form a second rectangle. We already have one, we will form a second rectangle. Yes. This makes sense. Let's see, hopefully this works. Yeah, let's go. Mm, Oh no. Okay, connect. Okay. Okay, let's solve another problem. Range sum of sorted subarray sums. Range sum of sorted subarray sums. 1502. 1502. I've already solved this problem. Let's see if I'm able to solve this again or not. A sequence of numbers. Problem number 1502. Wait, is this 1502? Is this 1502 or 1508? Okay, anyways, let's solve this problem. Problem number 1502. Can make arithmetic progression from sequence. Okay. A sequence of numbers is called an arithmetic progression if the difference between any two consecutive elements is the same. Okay. Mhm. Okay. Given an array, means this return when we rearrange to form this, and that's what. Okay, this is actually a very easy problem. How do I want to write this? This. Get the value of n, sort the array, r for int I equal to 1. If this is equal to 2, that is an interesting case, right? Should I return true or false? It should be between any two consecutive elements. Here it should be false, I guess. Let's see. This then this I is less than n minus 1, I plus plus. No, this is less than n minus, not n minus, no, n minus 2. Or let's say equal to n minus 2. Yeah, it should be equal to the n minus second character so that it can check the n minus 1th character as well. Okay, this makes sense. If hmm, if array of I, this is sorted, right? So array of I minus array of I minus 1 is equal to array of I plus 1 minus array of I. Wait, then return false, but just a minute, is not equal to this. If everything's fine, just return true and we should be good. But I want to see what happens if we have only two elements. Let's see. Let's check for this also. Let's try run for example 1 as well. I is 1, which is this, and I is n minus 2. It will be less than n minus 2, which is 3 minus 2, which is 1. So it will run only once, which makes sense, and check both them. Okay. I just need to check for n equal to 2. Yeah, it works. This will return true. Perfect, makes sense. Let's give a submit. And perfect. Okay. Now let's back to solving 1508. Range sum of sorted subarray sums. Okay. I hope I'm sharing my screen. Sorry. Okay. Problem 1508. Range sum of sorted subarray sums. You're given the array nums consisting of n positive integers. Okay. You computed the sum of all non-empty continuous subarrays from the array and then sorted them in non-decreasing order, creating a new array of this many numbers. Ah, just a minute. Wait, positive numbers. All non-empty contiguous subarrays from the array mm, from the array and then sorted them in a non-decreasing order, which is increasing, creating a new array of these many numbers. Return the sum of the numbers from index left to index right, index from 1, okay, inclusive, index from 1, inclusive. In the new array, in the new array. Okay. Since the answer can be used, return like how do you do this? Int mod 123 123 127. Put return something and then mod. Perfect. We have nums, we have n. Okay, left is 1, right is 5. All the subarray sums 1, 2, 3. Wait. All the subarray sums are 1, 3, 6, 10. Okay. What are the constraints? Oh, the constraints are pretty low, which is good. Okay, we can perform a n square solution on this. And then this. After sorting them in non-decreasing, we have this. The sum of the numbers from index 1 to this is this. Okay. Now, what is the sum of 1000 numbers? 1001 divided by 2. It is 5 lakh, which is 5 into 10 power 5, which should be fine. So we need to, yeah, we are just going to loop through the indexes, right, of that array, of this array created by this. Okay. This feels like an easy problem. Let's see. I less than 4. Oh, we do have n, actually. N, I plus plus. Da, 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 da. For int j equal to I, because we need to create all the sub-arrays. I, j less than n, j plus plus. Also, create an array of size. Let's define size. This will be n, oh wait, I need a bracket. N into n plus 1, the whole divided by 2. Right? Now, what we want to do is store at I plus jth index. Yeah, this should work. Right? Then just store the sum. How do we calculate the sum? Array of 0 equal to, even though this is already set to 0 initially in Java, but I'll just explicitly set this as well, equal to 0 as well. Okay. So what is the sum here? Oh, plus 1, because 1 based indexing will be equal to array of I plus j plus nums, or yeah, nums at j. and mod this value. Mod. Okay, cool. For int I equal to left, I less than equal to right, because it's inclusive, right? One, two, three, 4, 5. Yep. I plus plus, and we just int sum equal to 0, sum equal to sum plus array of I, and then mod. Now I think no need to mod, it's already modded. So just return this. Let's see. Out of bounds. How did this go out of bounds? Wait. Yeah, this should be size plus 1. Oh, wow. I'm returning double the answer that is required int I equal to. Oh, wait, because I have not sorted the array. Arrays dot sort arr. Wow. Let's just print all the values of the subarrays. Int I equal to n o plus plus. No. Size. Arr dot length. System dot out dot print arr of I. Yes. System dot out dot println. Yeah, let's see. Let's just store it normally. Let's see. But this will give out of index error. Oh, wait. This should be less. Oh my god. This should be size dot. No. Yeah. Size. My bad. Oh, no. This will be n only. Yeah, because we are looping over this array, nums array. Why? Why is it 0, 0, 0? In the first index, store the value of what was in the 0th index plus nums of j, that is 0. What is nums of j? It is 1. Then we move ahead, j becomes 1, which is basically at the second index, store value of the previous index, which is 1, which at index 1, which is the value is 1, and then nums of j. What is, wait, array of I plus j, which is the previous index, right? For j equal to 1. Yes, for j equal to 1, this will be j. Yeah, this will be the first index. This is the second index. This is the first index. In the first index, what did we store? Let's just write it down to be clear. When I equal to 0, j equal to 0, in that case, what did we do? Our ARR of 1 is equal to 0 plus nums of j, which is 0. Nums of 0 is 1 plus 1, which is 1. ARR of 2 will have ARR of 1, which is 1, plus nums of 1, which is 2 plus 2. So it should have 2 here. Let's just print what it is storing here. Plus j plus 1. Let's see. We should see something like 1, 3. Oh my bad. This is 3. 6, 10, and like that. Oh, dude. It should not take this much time. No way my net is that slow. Yeah. Okay, so we have 1, 3. The outer loop should be this, is what I feel. 1, 3, 6, 10. Where is 2? Wait, this, why do I not see 2? Where is 2? We directly have 5. Let's see, 1, 3. Array of 3 will have 3 plus equal to. Oh wait, after this I need to reset. Yeah, I need to reset. But how do I reset? Basically, what I mean is, when we start with a new element, we form new subarrays. right? Okay. Comment this for now. Just print nums of j. Just print nums of I, comma, nums of j. Nums of I. This, and then again println. Let's see what this prints. Nums of I. Oh, okay. So we have 1, 1, 1, 2, 1, 3, 1, 4. Let's just sum this up as well. Equal to nums I plus nums j. Let's go. Oh wait, I had to do nums I plus nums j, nums j. 2, 3, 4, 5. No, 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 no. I cannot do that because I need to store the prefix sum. 5, 6. Yeah. All subarray sums are this. I should just create an array list. Array. No, no, no. An array list. An array list of array list. Just create an array list of array list. ARR equal to new array list of array list. Oh wait. Don't do this here. Okay. Now every single time create an array list. Integer temp equal to new array list. This. Now just store the subarray sums in here. Temp dot add and we can store it in increasing order as well. No, 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 no need. No, 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 we cannot. Dot add. What do we want to add in here? the previous subarray sum plus this number just keep track of total int total equal to 0, total plus equal to nums of j, and just add total in here. Now at the end just add arr dot add 10 and we are good, right? We should be good. Now what we need to do is int I equal to z, no. Int what can we call this? Subarray sum. Subarray sums. This will be of size ta-ta, for int I equal to 0, I is less than what do you call this, size I plus plus. Just store everything for int j equal to 0, j is less than n. Yeah, just do this and we should be good. Now, how do I insert this array into this array? How can I insert the array values in how can I insert the array values in this? For this, get well, yeah, just oh my god, like, just initialize an id x equal to 0 for list. What can we from this? Yeah, r just for int val in list, sorry, this id x plus plus equal to val. Now sort this. I do want to print all the values here. I less than size like this plus. This is zero based indexing, but Yes. This will be left -1 to right. Perfect. Wow. Uh, now, I need to be careful here. Total plus this, and then just mod. Now, what? Why do I not have all the Subarrays values? 1, 2, 3, 3, 4, 5, 6, 7, 9, 10. Oh, I do have 1, 2, 3, 3, 4, 5, 6, 7, 9, 10 again. And then 1, 2, 3, 3, 4, 5, 6. Oh, we don't have it. This will be same anyways. Okay, this took. Yeah. Because I was printing this. We don't need this anymore. We are good here. Now just Subarray, this is this. We should be good. Perfect. It got accepted. Nice. Oh, wow. Whew. Okay, let's solve another problem. 375. Total waviness of numbers in range 1. I have solved this problem earlier. 3751. 37. Yep. I kind of know what to do here now. No point of solving it again. It's kind of like digit TP problem, the harder version of this. I've solved this in my first stream. My goal was to solve this, the second part of this problem in the first stream. You all can watch it there. Number of students unable to eat lunch. 1700 problem. Oh no, 1700 is the question. Problem number. Okay. This is an easy problem. the school cafeteria. How many problems have I solved? 243. Can I solve 250? Let's see. But first, I need to take some break. I will be back. Hmm. Okay, I am back. Let's solve some problems. Okay, we are on this problem. Let's go. Problem 1700. Number of students unable to eat lunch. Okay. The school cafeteria offers circular and square sandwiches at lunch break, referred to by numbers 0 and 1 respectively. All students stand in a queue. Okay. For each student either prefers square or circular sandwiches. Okay. The number of sandwiches in the cafeteria is equal to the number of students. Okay. The sandwiches are placed in a stack. At each step, if the student at the front of the queue prefers the sandwich on the top of the stack, they will take it and leave the queue. Otherwise, they will leave it and go to the queue's end. Okay. This continues until none of the queue students want to take the top sandwich and thus unable to eat. You are given two integer array students and sandwiches. Okay, where sandwiches I is the type of the ith sandwich in the stack. Okay, I equal to 0 is the top of the student. J is the jth student in the initial queue. Is front of the queue. Return the number of students that are unable to eat. Okay. Hmm. I will use okay. Return the number of students that are unable to eat. Okay. So student 1 uh prefers 1. This is 0. We move on. No. We move ahead the student to the next student. This is 1. This is 0. It's not matching. So we have a 0, 0. Okay. 0 and 1 not matching. We move again. 1 and 1. Okay. 1 and 0 not matching. We move ahead. 0, 0. Okay. 1, 1. Okay. Hmm. Okay. 1, 1. This. How many students will the number of students that are unable to eat? Okay. This is this. So 1 will eat. This student will eat. The student will eat. Okay. but then 1, 2, and 3. These students won't be able to eat. Okay, I think this is easy. Just count the number of ones and zeros in students and sandwiches. If the number of ones and zeros are equal in both students and sandwiches, in the students array and the sandwiches array, then you're good. No one will be hungry. Everyone will eat. If that's not the case, then we just return the absolute value of this and this, right? We just sum up this and sum up this, and then just return the absolute value by subtracting it. Okay, makes sense. Hmm. Okay, int S1, which is students 1, S0, then this is for, oh wait, this is student, this is sandwich, student. Okay, just count int I equal to 0, I less than int n equal to students dot length plus plus if students I equal to 0, increase this, else increase this. If this is equal to 0, then increase this, else increase this. If uh, this equal to this, and like student number of ones in the student is equal to number of ones in the sandwich array, return 0. If that's not the case, then sum up both of these things to total. uh, Okay, this will be signed, and then just return math.abs of this minus this. This is simple. Wait. 1, 2, 3, 4. Here we have only 3. This is 3. How? How? Why is this 0? Ah, println Student 1 sandwich 0 and then sandwich 1. Let's see. Mhm. 2433. Yes. Oh, wait. 2433. Yeah. This is 6. This is 6 as well. Okay. So, what we need to do is 4 minus 3. Okay. Just, no. Just check because zeros will be these zeros of the students array will become 0 because of this. Yeah. So we just need to find the max value. Right. Which one is bigger? That is causing the problem. Yeah. Yes. Then it will be mm, but then how is this possible? This gets consumed completely. Total number of sandwiches here is 3. Now, we count the total number here. Then we see, okay, we have 1. We only count the total number of ones and total number of. No, we cannot do that. No, or just say that initially the total number of students who are hungry is the length of this. Everyone's hungry. But then we see 1, we get 1. Okay, just remove it. We see 0, we see 0, remove it. We see 0, we see 0, remove it. Now the problem is this 0. We don't have any number of students with 0, but we have number of sandwiches here for 0. So this is the problem. So we return this will, one of the numbers will become 0 here. So we return, just sum them up and then return net. I guess that's, yeah, that's correct. No, no, no. We know that if we subtract 2 minus 0, okay, so we have two zeros, right? We iterate, we iterate 2 times, and then subtract the number of ones. Hmm. This. No, we have this. If if what do we call this? Student 0 minus sandwich 0 is less than 0. It is less than 0. Then we create int students equal to 0 initially and assign students equal to student count 1. Else give students equal to 0. 0. Okay. Now we iterate over sandwiches, and if not n times, how many times? Student 0 amount of times. No, 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 no. Yeah. If this is 0, then n becomes equal to student 0, n becomes equals to student 1. If n is less than, no, no, no. If, what is this? Sandwiches of I equal to check equal to 1. And check equal to 0 initially. Check equal to 0. Then we reduce this value and then just return students. Oh, this is such a not a good or very good. Oh wait, student. Oh my god, this, why did this check get removed? Where if, oh my god, I have to write this again. This equal to this, and this equal to this, return 0. Boom. I would like to check still. Will my solution pass all the test cases for dropping? If sandwich is 0, count students pointing 0. Yes. For each sandwich, if 0, sandwich equal to 0, if mm, right, right. That's what I'm okay. That's what I'm doing, but in a complicated way. I'm counting this for int I equal to 0, I less than n I plus plus. If sandwiches of I equal to 0, check if student 0 is equal to 0. If it's 0, just break. Otherwise, yeah, student 0 minus minus. Else, if student 1 equal to 0, break. Otherwise, student 1 decremented. Then at the end, just do this. Yeah, that's I was doing. This is exactly what I was doing, but in a complicated manner. What? My idea was correct, just the implementation. Big bad. Somewhere. Okay. Find positive integer solution for a given equation. 237. What are these problems? Problem number 1237. Find positive integer solution for a given equation. Given a callable function f x comma y with a hidden formula and a value z, reverse engineer the formula and return all the positive integer pairs x and y where f of x comma y equal to z. You may return the pairs in any order. While the exact formula is hidden, the function is monotonically increasing. That is, f of x of y is less than this, than this. The function interface is defined like this. Oof, what is this? We'll judge your solution as follows. The judge has the list of 9 hidden implementation of custom function along with way to generate an answer key of all valid pairs for specific z. The judge will receive two inputs, a function ID, determine which implementation to test your code with, and the target z. The judge will call your find solution and compare a result with the answer key. If your results match the answer key, your solution will be accepted. Function ID is this z equal to 5. The hidden formula for function ID equal to 1 is x plus y. The following positive integer values of x and y make equal to 5. What is it? The hidden formula function ID is 1. The following positive integer values of x and y make f of x minus 1 equal to 5. So, what? No, I'm not solving this problem. Find count alternating subarrays. This is a 2, 3. 3, 1, 0. 3, 1. 1, 0 or opposite 0, 0. You are given a binary array nums. We call okay. Problem 3101, counting alternating subarrays. You are given a binary array nums. Okay. We call a subarray alternating if no two adjacent elements in the subarray have the same value. Return the number of alternating subarrays in nums. Okay. 1, 2, 3. Okay. This. This is 10 power 5. Nums I is either 0 or 1. Okay. So we have 0, comma 1. Okay, this is alternating. So the count increases. No, this is a DP kind of problem, right? Let me think. Yes. Okay. I think this is better. Okay, let me see the problem first. We have nums 0, comma 1, comma 1, comma 1. Okay, so let's check. We are currently at the 0th index. We check ahead. We have to declare a DP of size n plus 1. DP of size n plus 1. So, and in the 0th index, the value will be 1 because there are no subarrays, so the answer will be 1. So, we have 0 here. We look at the previous index, which is in this case dp of I. This will be dp of I. So dp of I plus 1 will be equal to dp of I. Sorry. Uh, no, dp of I will be equal to dp of I minus 1 plus nums of I minus 1. Right, we are standing at the current index. We check what are the subarrays that the up to n I minus 1 dp contains, and add now here we again have to check whether or not the previous element and the current element are same or not. If it is different, we just add plus 1. If it's not different, we add 0. So we need to add a check here, or a if condition basically. Okay. And then dp of n will basically contain all the subarrays that are possible up till n. This kind of makes sense, I think. Let's see. Yeah. What are the constraints? Yes. Okay. Why is this long? Return the number of. Oh yeah, because we will be adding, I believe. That's fine. Return the number of alternating subarrays in num. So int dp, let's set it to int initially. Let's convert it to long later. Int of int n equal to nums dot length. This is n. Now we initialize dp with c of 0th index with 0. For int I equal to 1, I is less than equal to n, I plus plus. Let's see. Oh, this will be equal to 1. Bad. Return the number of alternating Subarrays. Right. So this is 1. dp of I will be equal to dp of I minus 1 plus. Now we need to check if nums of I no, we do this because we have nums of I here, right? If this is not equal to the next character, is not equal, then return 1, else return 0. Plus 1, and then yeah, return dp of n. Let's see if this works or not. How is this going out of bounds? Oh, because it's should be n plus 1. Yeah. Oh yeah, we are also checking this. So will this this is a GB problem for sure. To what if I do this? It will give 0, I believe. Yeah, yeah, 2 and 4 now. But let me print all the GP states then. System. And then GPI plus 1. Two, two, two. Here, do we add plus 1? Yeah, we add plus 1 because individual is also an array subarray. Yeah, this is correct. What happened to this? Let's see. This is basically dp of 0 will be 1. Then dp of 2 will be 1 plus. So basically this is We have 3 subarrays here. Now we should have 2 subarrays here. Then here we should have we already have 2 subarrays. We should add one, so 3 and 0 comma 1. Oh no 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 no. Oh no no no. Yes, we have 3 because 0, 1 and 0 comma 1. So we have 3. This is correct. Then 1 comma 1, 1 comma 1. This is not same. So we check how many subarrays do we have here still. So we currently have 3 subarrays. Then 1 comma 1 is not same. So return 0, but this one individually is a subarray. This one is individually a subarray. So count 1, which is 1. Again, this will ask for previous. We have 4, 4 comma 1. This is same. So no, this will add 1, which is 5. But we never go on and check this, the last element. Now, but we have already checked, right? Because we have already checked. There is no subarray after that. I think this is correct for this, yeah. Let's see why this is wrong. But before that, I need to go to the show. Just give me a minute. I will be back. Okay, let's go. Let's continue with that problem. Hmm. I believe we should try run this. Yes, view. I think I will turn this on. Yeah. Okay. Hopefully I'll consider this. Hmm. So let's see on which test case it was failing, right? It is 1 comma 1 comma 0 comma 1 comma 0. So initially our dp of 0 is set to 1. dp1 will be what will it be? This is 1. It will check if the next element and this current element are same or not. In this case, they are not. So we'll get 1 plus the previous dp value, which is 1, 1 plus 1, which is 2, and the self subarray thing, which is plus 1. So total will be 3. We have here 3. dp of 2 will contain 3 plus this and this element are different. Plus 1 plus 1, which is 5. dp of 3, 1, 1 and 0. This is different. So 3, so 5 plus 1 plus 1, 6, 7, 7. Now, hmm, We have 7 here, but yeah, we also need to check for this, right? DP of 4. We're checking the next element. I think we should check the previous element, right? Hmm. Yeah, we should check the if you're standing on this element, if the previous element is same or not. Hmm. DP of I should check up till this point whether or not how many subarrays can we form, right? So I need to change a bit of wording here. I need to stop sharing this. This is this. Let's see. At the ith index, how many subarrays can I form? At the 0th index, it will be 1. At the 1th index, it will be dp of I minus 1 previous this plus check if this is ahead, right? dp is indexing. So check if at the 0th index of nums, if this is at the 0th index of num, we'll just add plus 1. Yeah. So if I minus 2 is equal to 0, then what should we do? If this is 0, return 0. Wait. If I minus 2 equal to 0, then dp of I equal to dp of I minus 1 plus 0 plus the current this one. So plus 1. Now this will be only dp of I minus 1. Yeah. Else dp of I will be equal to dp of I minus 1 plus, yeah, here we need to set dp of 1 equal to 1 as well. If you have one element in there, okay, so we need to make sure that this is at least equal to 2 length, otherwise just return 1. If I equal to 0, this. Just check if dp of I equal to dp of I minus 1 plus just check if nums of I minus 1 is not equal to nums of I minus 2. If this is true, return 1, else return 0. And also add plus 1 for because the self subarray thing. Minus 2. Okay, this should work. And then return dp of n. Oh my god, nums. Yeah. Yeah. Print the current state of the dp. Why is this wrong? Let's see. You know what? I will just let's just ask this. What is wrong in my code? It's done. Mm, if this is not this, dp equal to dp plus 1, else dp equal to 1. Answer. What? Number of alternating survivors ending at the current index. Oh yeah. Wait. It dp plus 1. No. Check the previous index. If this, then this should be equal to oof, this should be equal to 3 initially because individual subarrays and then both then the subarray containing both the elements. Now start with dp1 extends previous. This is this. The total count. There should be dp plus. Here we should have a plus symbol, which basically means dp plus 1. dp plus dp plus 1, yeah. Okay, Oh yeah, that's what they're doing here. I believe, yeah. Yeah, that's what they're doing, counting the number of subarrays. This will be 2, so 1 plus 2, which is 3 perfect. Yeah, this is correct. That's what I'm trying to do in my code. But then when nums of I is not is equal to this, we start a new subarray. Yeah. So this becomes equal to 1. This does make sense. Yeah. Yeah. Count the number of subarrays until we find same numbers. Hmm. Okay. So this will be count of subarrays and then total. For int I equal to 1, I less than n, I plus plus. I had the idea correct. I had the correct idea, but then this is what failed. The implementing part. If nums of I and is not equal to the previous nums I minus 1, then the count becomes equals to count plus 1 or just count plus plus. Else count becomes equal to 1 again, and then we add it to our total count. Yeah, return total. This is long. Hopefully this works. If they are same, start fresh. Oh yeah, this should be 1, and this should be total count should be 1 as well. Or it should be 1. Or just for durability count. Yeah. Yeah. I knew the technique of counting the subarrays. Yeah. Git add, git commit. Let's solve another problem. Let's first see how many problems have I solved yet. 245. Okay. Wait, I need to check something. 11 submissions. What do we have here? Next problem. Pseudo-palindromic paths in a binary tree. Oh wait. Palindromic paths in binary tree. Okay, problem 1457, pseudo-palindromic paths in a binary tree. Given a binary tree where values are digits from 1 to 9. Okay, a path in a binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. If at least one permutation of the okay. Return the number of pseudo-palindromic paths going from root node to the left, to the leaf nodes. Okay. Hmm. The number of nodes in the trees is in the range this. Okay, but the values can be only from 1 to 9, which is good, which is very good. Hmm. What should we do here? The figure above represents the given binary tree. There are three paths going from the root node to the leaf node. It is okay. Return the number of pseudo-palindromic paths going from root node to leaf node. Okay, this is an important detail. Going from root node to the leaf node. We have there are three paths from root node to the red path 2, 3, 3, the green path 2, 1, 1, and the path 2, 3, 1. Okay. Among these paths, only red path and green path are pseudo-palindromic paths, since the red path is this can be rearranged. Okay. So what I can think is as soon as you see a node, add it to a list. Of course, we have to perform a DFS here. As soon as you see a node, add it to a list of a map, hash map, to check its frequency, right? Now, as soon as you reach the null point, we add a condition and check whether or not that list is even or odd. The size of the list is even or odd. If the size of the list is even, we just check if uh the total number of frequencies is even or odd. If any frequency becomes equal to odd, we just return false or 0 from there. If there is a way to form a pseudo palindrome or to form a palindrome, we return 1. Okay. I think this is doable. Let's see. DFS root, then we send the initial value. No. We don't send the value. We create an array list of integers. Yeah, int value. So integer, what do we call this? A list equal to new array list. Done. And we pass a list. public int dfs tree node root, and we have an array list of integer also known as list. If root equal to null, return check no no yeah return check palindrome, and we send the list. If this returns true, return 1. If false, return 0. Okay, public boolean, oh sorry, check palindrome, and then just copy paste this. Okay, we'll create that function later. But first, let's check. Let's write the logic here. Hmm. What do we do? List dot add the current root value. We add the current root's value to the list and call the DFS root dot left list root dot right list, and then this is basically like what do you call it? We are adding value of root to the list and then removing the value of the root value and then trying to explore. What do you call this? Add, search, and then explore, and then correct yourself again. This is called something I'm forgetting, but it's int result equal to 0, result plus equal to this, and result plus equal to this. At the end, return result, but before that, we need to remove list.remove last. I believe this is a function. Yeah. Now we check whether or not it's palindrome or not. We can create a palindrome from it or not. First, int n equal to list.size. If n is even, oh wait, we cannot, oh, no, we cannot pass a list. This needs to be a hash map of integer, comma, integer frequency. This is frequency. This is frequency. Okay. This is frequency. Frequency. Mhm. So here we add frequency dot put frequency dot put root dot value frequency dot get or default the root dot value or check it to 0 and then +1. Now frequency dot put root dot value and frequency dot get root dot value -1. So decrement the frequency of this root dot value and then add the root dot value. Okay, if frequency dot size is even, how can we if my hash map value, not the key, the value becomes equal to 0, remove, how can I remove that key from the hash map? Mhm. Okay, so we decrement this and just add a check if frequency dot get root dot value equal to 0, then just frequency dot remove root dot value. Does this make sense? Yes. Spin. Okay. This is fine. Okay. If n equal to, if n is even, check for map dot entry integer integer e equal to frequency dot entry set. What do you want to do here? Int key, no, int value e dot get value if value is not even, check if n is even or not. If it is even, return false. Else set meg to true. We also need another boolean meg, initially it's false, if this is even, or check for meg. If it's odd, then you can set this. Okay, this is fine. But if the value is even, we are good because we can place it at both the ends. That's it. Let's check this works or not. Oh wait, I need to return something here, right? If this passes, return true. And this is true. Okay, let's see. This is correct. This becomes null. Check if we can create palindrome or not. It does. Check if we can create palindrome or not. Check we can create palindrome or not. We just want to remove the last element, right? Should I? Is this placement not right? Uh, this removal part. What if I place this here? This is I'm off by 1. Let's see. Let's say, so this is fine. Here, is this. After returning from here, remove this. Check for this. We go right. Add. Once we go right, we add this value. We don't have anything in the left. We come here again. We move on to the right. No. No, but this is not the end, right? So we need to find till root dot left and root dot right both needs to be equal to null. That's the only correct path. Yeah. If root dot left and root dot right equal to wait, if root yeah and root dot right is equal to null, check this. If at all we reach a point where if root becomes equal to null, just return should we return 0? Yeah, return 0 if root becomes equal to return. Okay, this is it should be good. Yeah, but before doing that we need to add, oh wait, both the values is null. So yeah, we need to add frequency dot add root dot value, which is basically the root node's value or the leaf node's value basically, and do this. Okay, let's see. Semicolon. Okay, so the frequency dot put. Yes. Uh, should I submit this? I should. Yeah. 8, 8, null. 3, 1, 3. One, one, 7, 1, null. 2, 1, 1, 1, 3, null, 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 then 1. Why is this? So let's create this binary tree, but not binary tree, a normal tree. Oh no, it is a binary. Okay. We have 8. Let's open the SQ, start this view, this OBS. We have 8, then 8 again. Here it's null. So 7, comma 7. Null, null. 2, 4, null. 8, null. 7, null. And then 1. Okay, let's see. Yes. Oops. Oh, we can see the binary tree here as well. 281. So what we have created here is correct. Yeah, this is correct. Hmm. Okay. So according to my solution, what do we do? We move left Adding this value means left, 7. We are at 7. Both of the child value is null. So we come here, we put frequency of 7, add into the frequency hash map, then check for palindrome. This is the only case we need, right? We don't need any other case. If one, this needs to be even. I guess the check palindrome is correct. If value is this, or should this be the, oh my god, this condition should be here. Wait, is this right thing? Oh no. This is perfect. Let's see. This is equal to 0, but expected output is 2. I can see that this is a palindrome, like pseudo-palindrome. 1, 2, 3, 4, 5, 6. This cannot be a palindrome, so 1, 2, 3, 4, 5. And then this is a palindrome as well. So there are two palindromes. Always strong. It's the errors. This is a good problem. Check palindrome logic is how is this important? It may first if this is just number of distinct digits, not path length. Oh, yes. We need the number of distinct digits. Count this if this is, yeah, we don't even need this. if value is this, or no, if value is this, then just check if meld is true or not. If meld is true, this will be false. Otherwise, this set make to true. Return this should be correct. Missing backtracking for leaf node. I had a doubt this will cause an error. Returning without backtracking. Wait. Let's do this. Okay, I had a doubt this will cause an error. Okay, this is correct. We'll create a Boolean check. I should just use this Boolean check and then call this function here. Call this function here. Now we remove frequency dot put root dot value frequency dot get root dot value -1 if frequency dot get value equal to 0, then frequency dot just remove this root dot value. Does this make sense? Yes. Now just see if this is true or not. If this is true, then return 1, else return 0. This should yeah, frequency dot get value of root dot cos as state. Okay. This is correct. Should I submit it? See, do I have any other errors? Yeah. Do presentations. More optimal bit mask solution. Yes, I can do. But oh wait, how can I do a bit mask solution? Sure, do it. Yeah, we have one for now, but how do you store the frequency? Oh, no, I'm good. I'm happy with the solution. Yes, it's pretty slow, but I'm Wait, let's search it on YouTube. Remove this. 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 I'm just trying to find the video about topic. Okay, LeetCode has uploaded a video on it. Nice.
Everyone, welcome back, and let's write some more neat code today. So today let's solve the problem pseudo-palindromic paths in a binary tree. We're given a binary tree where the values are only going to be in the range from 1 to 9. And in this problem, we care about the paths in the binary tree that go from the root down to the leaf nodes. We want every single one of those such paths. That's one, this is another one, and lastly, this is one as well. So there's 3 paths, right? And that's because there are 3 leaf nodes, of course. Now, for each of those paths, we want to first get the path itself. So actually, does a possibility to it. We don't want to get every single. Try to introduce.
Okay, I want to see how he solves it using bit mask. I've solved this problem. I just want to see how to solve it using the bit mask.
Of times. In other words, if we were to take any such string, any possible string, and for every single digit, we want to map it to the count of that digit. And we must ensure that only at most one digit occurs an odd number of times. So if we have this mapping, we can then get the number of digits that occur a little bit. We have, that means such path down to every single node will have be big. Okay, so the first thing this is doing is to have an else statement over here function, like not using odd from outside, you're actually declaring a new version. Let me just run this to on that we're actually not declaring a new odd value down here. We're actually using the odd from out here. That's the entire code. Let's run it to make sure that it works. As you can see on the left, yes, it does, and it's pretty.
Okay, so he doesn't use bit mask here. Yeah.
Hello everyone, welcome to my
uses
channel
bit mask. Let's see.
कोड स्टोरी विद माइक। तो बिल्कुल भी मीडियम नहीं, 2 बहुत वीडियो नंबर 38 करने जा रहे हैं। LeetCode 1457 बिल्कुल भी मीडियम नहीं, 2 बहुत ही आसान तरीके से इसको बनाएंगे। डिजिट्स फ्रॉम 1 to 9, ठीक है? नहीं, सही बात है, इस पाथ में कोई 0 नोड है ही नहीं। इंडेक्स नंबर 1 4 4 नंबर ऑफ टाइम्स का लेफ्ट लौटेगा, बाकी तो सबसे क्या करना है, रेट जाएंगे। मतलब खुद ब खुद पास मान ले
Kafka and
मैंने बाइनरी ले लिया जिसकी वैल्यू 0 है।
Okay, this is using the bit mask, I believe.
तो फर्दर फॉलोअप क्या किया जा सकता है इस अप्रोच को, ठीक है? अब देखो फर्दर फॉलोअप क्या सकता है, इंटरव्यूअर आपसे पूछ सकता है कि कैन वी गेट रिड ऑफ पासिंग द वेक्टर, जो काउंट वेक्टर हम बार बार पास कर रहे थे ना, ठीक है, और इसी से चेक करना पड़ रहा था बार बार। इसमें जब भी पाथ कंप्लीट होता था तो बार बार आप इस वेक्टर पे इटरेट मारते थे और ऑर्डर फ्रीक्वेंसी का काउंट चेक करते थे, राइट? तो इसको अवॉइड किया जा सकता है क्या? देखो कैसे कर सकते हैं। देखो क्वेश्चन में बोल रखा है ना कि आपके जो ट्री के वैल्यूज हैं वो 1 to 9 ही होंगे और कुछ नहीं हो सकता, ठीक है? तो मैं क्या बोलता हूँ ना कि ये फ्रीक्वेंसी वेक्टर की जरूरत ही नहीं है आपको, ठीक है? अगर मान लेते हैं अभी रूट की वैल्यू 1 है, ठीक है, ये मान लेते हैं मैंने बाइनरी ले लिया जिसकी वैल्यू 0 है, वैल्यू 0 इसकी, ठीक है, स्टार्टिंग में इसकी वैल्यू 0 है। मुझे रूट में क्या मिला, मुझे रूट में 2 मिला, तो बता मैं क्या करूंगा, मैं इसका 0 बिट, फर्स्ट बिट और सेकंड बिट, टूथ वाला बिट, ये मेरा क्या है, सेकंड बिट को मैं सेट कर दूंगा। इसका मतलब क्या हुआ कि अभी मुझे 2 दिखा है, यहाँ तक क्लियर है? ठीक है, तो मैंने क्या किया, सेकंड बिट को 1 कर दिया। और आपको अच्छे से आता होगा, मैंने कितनी बार आपको पढ़ा दिया है कि किसी भी बिट को 1 सेट करने के लिए क्या किया जाता है। बहुत आप 2 टाइम्स लेफ्ट शिफ्ट मारो, ये मान लेते हैं आपका 1 है, पता था। उसके बाद जो मेरा ये वैल्यू है उससे और ऑपरेटर ले लो, और ऑपरेटर ले लो, क्या होगा, 0 0 1 0 0 0 0 एंड सो ऑन। अब ध्यान दो, रिजल्ट थर्ड वाले बिट को सेट कर दूंगा, तो 1 था ये 0 0 0, ठीक है। उसके बाद देखते हैं, उसके बाद है 3, फिर से 3 आ गया, ठीक है। अब देखो ध्यान दो, फिर से 3 आया तो आपको क्या करना है, थर्ड बिट को सेट करना है। अरे भाई थर्ड बिट तो ऑलरेडी सेट है, तो आप पता कैसे कर पाओगे कि भाई 3 जो है तो 2 बार आया है, तो और नहीं करेंगे, इस बार जोर करेंगे। और आपको अच्छे से याद होगा, ऐसे यूज केसेस में हमेशा जोर यूज करता है, जो डुप्लीकेट नंबर को नलीफाई कर देता है। मतलब जोर का मतलब क्या होता है कि ए जोर ए 0 होता है ना, मतलब सेम
Yes.
एलिमेंट।
Okay, this is pretty efficient. Yeah. I understand it now. Okay. If we see the same number again, we just use a XOR. Makes sense. But and at the end, when we reach the root, we just check if the size of that path is even or odd. If it is even, we should have all the bits set to 0. If any bit is set to 1, we'll just return 0, which is false. That you cannot form a palindrome using it. If it is odd, if the length of the path is odd, you need to check that only one bit is set. If more than one bit is set, then it's again a case where you cannot form a palindrome.
को सेम एलिमेंट से जोर करोगे तो वो 0 आ जाता है, ठीक है। तो हम लोग क्या करेंगे, ये जोर लेते चलेंगे, इसको सॉल्व कर सकते हैं। तो स्टार्टिंग में मैंने बोला था कि अभी तो मुझे कोई एलिमेंट नहीं दिखा है, तो ये स्टार्टिंग में मेरा 0 है, जो भी मेरी वैल्यू है उसकी बाइनरी डेसिमल वैल्यू 0 है, तो बाइनरी रिप्रेजेंटेशन कुछ ऐसा होगा। अभी मैं रूट पर आया, ठीक है, मुझे दिखा 2, इसका मतलब 0, ठीक है। तो मैं फिर वही करूंगा, 1 को 3 बार लेफ्ट शिफ्ट मारूंगा, तो 0 0 0 1 आ जाएगा। ये मैंने कैसे निकाला, 1 को लेफ्ट साइड शिफ्ट किया 3 बार, बाकी 0 है। फिर से जोर लिया इनका, ठीक है, फिर से इन लोगों का जोर लिया, तो क्या आ गया, 0 0 1 1 0 0 एंड सो ऑन, ठीक है। अब आ गया लेफ्ट साइड में, मैं गया तो मुझे वापस से 3 दिखा। अब देखो ध्यान दो, अब आएगा मेन पार्ट, फिर से 3 दिखा तो मैं 1 को लेफ्ट शिफ्ट मारा 3 टाइम्स, ठीक है, 0 0 0 1, ठीक है, 1 लेफ्ट साइड शिफ्ट 3, बाकी 0 है। अब देखो ध्यान देना, अब मैं जोर ले रहा हूँ, ठीक है, तो 0 0 1 रहेगा, ये देखो 0 हो गया, बाकी सारे 0 हैं। यहाँ तक क्लियर है। अब एक चीज़ ध्यान दो, अब तो 3 के नीचे मुझे जाना है नहीं, क्योंकि लेफ्ट साइड राइट साइड नल है, ठीक है। तो मैं देखूंगा कि मतलब ये मैं लीफ नोड में आ गया हूँ, अब मैं देखूंगा कि क्या वैल्यू है इसकी, ठीक है। अब देखो ध्यान दो, इसमें सिर्फ एक ही बिट सेट है, इसका मतलब पता क्या हुआ कि बाकी जो सेट बिट्स थे या तो वो कैंसिल आउट हो गए होंगे जोर की वजह से। क्यों कैंसिल आउट हो गए, क्योंकि वो इवन नंबर ऑफ टाइम्स आए थे, और हमको एनीवेज इवन नंबर टाइम जो भी एलिमेंट्स आ रहे हैं फर्क ही नहीं पड़ता, क्योंकि एनीवेज वो दिक्कत नहीं क्रिएट करेंगे, है ना। 0th बिट फर्स्ट बिट, ये सेकंड बिट है, इसका मतलब क्या हुआ कि 2, ठीक है, एक बार आया था। इसका मतलब क्या हुआ, तो कि एकमात्र यही एलिमेंट है जो एक बार आया था। अब देखो ध्यान दो, इसके अलावा कोई भी एलिमेंट ऑड नंबर ऑफ टाइम्स नहीं आया है, ठीक है। और आपको अगर ये पता करना है कि कोई भी बाइनरी रिप्रेजेंटेशन में सिर्फ एक ही सेट बिट है, तो कैसे पता कर सकते हो, मान लेते हैं इसकी वैल्यू अगर 1 है, ठीक है, इसकी वैल्यू अगर ये है, वैल्यू नाम का वेरिएबल ले लिया, तो अगर बहुत सिंपल है, वैल एंड वैल माइनस 1, ठीक है, अगर ये 0 के बराबर हो गया, पता है इसका मतलब क्या हुआ कि इस वैल में पक्का सिर्फ एक ही बिट सेट रहा होगा, ठीक है। भाई पावर ऑफ 2 का मतलब क्या होता है, ये देखो कर रहा हूँ कि ये जो वैल्यू है ना, पावर ऑफ 2 है कि नहीं। भाई पावर ऑफ 2 का मतलब क्या होता है, ये देखो पावर ऑफ 2 है, 1 2 4 है ना, 2 का पावर 2 है ये, क्योंकि भाई सिर्फ एक ही बिट सेट है तो पावर 2 ही होगा ना वो, ठीक है। बिट में इतना तो आइडिया होगा आपको, ठीक है। जैसे मान लेते हैं 8 है, इसकी बाइनरी रिप्रेजेंटेशन लिखो 1 0 0 0, ठीक है, देखो ये भी पावर 2 है, सिर्फ एक ही होगा आपको, बस ऐसे सिंपल जो भी वैल्यू है एंड वैल माइनस 1 से एंड ऑपरेशन कर दो, 0 आना चाहिए, ठीक है। यहाँ तक क्लियर है। नॉर्मल से आप चेक भी करके देख लो, मान लेते हैं 8 आपका ये है, 1 0 0 0 है, 7 ले लो, 8 माइनस 1 है ना, ये 7 क्या होता है, 8 माइनस 1 होता है, इसका क्या हो जाएगा 0 1 1 1, दोनों का एंड ले लो, देखो 0 आ जाएगा, है ना। वही मैं यहाँ पर दिखा रहा हूँ कि जो पावर 2 है ना, उनका वैल एंड वैल माइनस 1 0 ही होता है। तो इस केस में मैं समझ जाऊंगा कि सिर्फ एक ही एलिमेंट था जो ऑड नंबर टाइम्स आया था, क्योंकि एक ही बिट सेट है और वो पावर 2 है, इसीलिए तो रिजल्ट प्लस प्लस कर दूंगा इस केस में, नहीं हुआ तो नहीं करूंगा, और क्या। यहाँ तक क्लियर है। तो आपने नोटिस किया होगा स्टार्टिंग में मैंने दूंगा इस था जो ऑड होते हैं ना, इसका क्या हो जाएगा 0 1 1 1 है, दोनों का एंड ले लो, देखो 0 आ जाएगा, है ना। तो वही मैं यहाँ पर दिखा रहा हूँ कि
Okay.
था जो ऑड नंबर ऑफ टाइम्स था क्योंकि एक ही बिट सेट है और वो पावर 2 है, इसीलिए मुझे 2 दिख चेक कर लेते हैं और जोर क्यों है ताकि जो इवन नंबर ऑफ टाइम्स आए हैं ना जो एलिमेंट वो कैंसिल आउट कर है।
We are looking for
Okay. Skip.
तो इसकी बाइनरी प्रेडिक्शन कुछ ऐसी होगी 0 1 2 3 4 5 एंड सो ऑन और ये भी सेट रहा कि ऑड नंबर ऑफ टाइम्स आए और दूसरी बात कि भाई ये पावर ऑफ 2 है ही नहीं, है ना, इसकी ये वैल्यू ना, तो अगर वैल एंड वैल नंबर ऑफ टाइम्स आए हैं सिंपलीफाई कर लिया और
Nice. Okay. Copy this. Visual Studio Code. I will create a folder. I will solve using the other way as well. Mhm. Oh, okay. Yeah. Right. Push. Okay. So we need a mask here instead of frequency. And mask equal to 0. Just saying this mask. We don't need this. Mhm. We don't need to check this. Return and mask. Also, we need to send the length of the path as well.
अब हमें वेक्टर भेजने की जरूरत नहीं है, हम सेम जल्द को हम इंप्रूव कर निकलता चला।
Wait, I have the code here. Oh, we don't need the length as well. If mask and is 0 quarter, yeah. If n is even and mask should be 0 0 and mask and the previous value will be equal to 0 if mask is 0. Yes. If n is odd, mask and mask minus 1 should be, yeah. This is correct. Just return if mask and mask minus 1 equal to 0. Otherwise, yeah, return 1, otherwise return 0. Okay, this is this. This is now. We don't need this. Wow. We don't need this. Okay. Let's run the code. Oh, wait. Huh. This is, yeah. Why is this wrong? Oh, wait. We need to check if mask XOR equal to 1 left shift root dot value amount of times. And here also we need to do the same. Yes, not here, here. This should work. Oh, mass, mass. Perform the AND operation. Return this. Yeah, just do this. We can do this as well. Why is this wrong? Bad binary operator. Is this because of this? Let's see. Uh-huh. Put this, make a new file. Okay, get add, get commit, get push. Oh, okay. Okay, let's solve another problem. Lexicographically, smallest string after substring operation. 273. 34% acceptance rate. Lexicographic. Problem 2734, lexicographically smallest string after substring operation. Given a string S consisting of lowercase English letters, perform the following operation. Select any non-empty substring, then replace every letter of the substring with the preceding letter of the English alphabet. For example, A is converted, sorry, B is converted to A and A is converted to Z. Return the lexicographically smallest string after performing the operation. Oh, this is a not a medium problem. This is a medium hard problem. Lexi I remember this problem because it was asked in a weekly or bi-weekly contest. Yeah, weekly contest 349. This is a hard problem. Like it requires a inbuilt function in C++. In the definition section. Oh. Just just keep your topics. Oh. Hmm. A, B, A, A. C, 2, 7, 3, 4. Oh.
The University of Melbourne pushed
Everything.
Hey everybody, this is Larry. This is me going Q2 of the weekly contest 349. Lexicographically, a smaller string after substring operation. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, to be honest, I kind of missed the A is converted to Z one. This is not really a full example. This is not an example. This is not a general interpretation of previous character. Previous character of A is not Z. I just thought that you have to. I just thought that you know. And that's why I got one wrong answer. But yeah. Answer. I just thought that you know. And that's why I got one.
Those are cool.
But yeah. But basically, you just have to keep. There are a couple of observations. Basically, you just have to do greedy. The thing about lexicographically smallness is that you want to, if you're able to minimize the beginning, that's all that matters, right? So you greedily minimize the beginning as much as you can. If you have an A, you don't minimize it because otherwise it becomes a Z. But if it starts with an A, then you could minimize the second and so forth, right? Because the first one is optimized. So another way to say that is that you could be like, okay, can I fix the first one? Can I fix it for the second counter? And so forth, and greedy in that way. The only thing that this problem is a little bit tricky about is that you are required to the only thing that is required is that you have to do at least one operation. And because you have to do at least one operation, if your string is all A's, you have to convert at least one of them to a Z. And that's basically the edge case. Because I don't know, why is this an assumption? Like, why is this an example? But anyway, this is my code. Basically, I skip the beginning A's, and then I see if I can, convert at least one character. And, the earlier the better. And then if there's any characters left, of course, we do not convert A. If there are any characters left, we just put it back on the string. If we did change at least one character, that's the answer. Otherwise,
Hey, correct.
we remove the last character and add Z. That's all I have for this one. This is linear time, linear space, and it's just observation and greedy. Yeah, that's all I have for this one. Let me know what you think, and you can watch me solve a live contest now. We'll take it a while.
SQL will. This was made. Most people believe.
Hello, 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 hello everyone. I hope you're doing well and welcome back to the channel. My name is Sayam, and if you're new to the channel, make sure to subscribe or either we solve the question, right? So don't worry if you're not in operations. Okay, कोई दिक्कत नहीं है. You are given a string of even length, okay, consisting of digit even length. Okay, this is maybe useful. I don't know. Consisting of digits from 0 to 9 and two integers a and b. Okay.
Hey, everybody, this is live. This
I'll eat something and be back. Okay, I'm back. Hmm. Okay, so we were solving this problem. Let's see. Did I do an intro of this? I guess not, right? First, okay. Problem 273. Fourth lexicographically smallest string after substring operation. Okay. Given a string is consisting of lowercase English letters, perform the following operation. Select any non-empty substring, then replace every letter of the substring with the preceding letter of the English alphabet. For example, B is converted to A and A is converted to Z. Okay. Return the lexicographically smallest string after performing the operation. Okay. First of all, I need to write down the A, B, C, D, just for my reference. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q R S T U V W X Y Z. Cool. So what is this? Return the lexicographically smallest string after performing the operation. Select any non-empty substring, then replace every letter of the string with the preceding letter of the English alphabet. For example, B is converted to A and A is converted to Z. Z. Hmm. What is this? Okay. So we need to make this string lexicographically smallest. Let's see. We have C, B, B, C, B, A, B, C. Converted our output is perform the operation on the substring starting at 0 and ending at 1 inclusive. C is reduced down to B and then we have B again. Let's see what this means. A string is called lexicographically smaller than a string B if in the first position where this is corresponding letter in B of the first okay. Huh. So what I think is what we can do is first check for all first check for all the character A for all the characters containing A and then we need to reduce that. Yeah, A won't reduce to Z because it will not be smaller than. So after A, change the next character and reduce it yeah, by 1 and check if B is equal to the next character, this current character is equal to the next character, then reduce this value as well. If it's not same, then leave it as is. Okay, so int length equal to s dot length. Okay, let's just call it 10. So we need to take care of the A's first. While int I equal to 0, let's name it this idx. While idx equal to while idx is less than n and then id and s dot char at idx is equal to a. What do? We just increment the value of idx, right? That's what we can do. That's the only thing we can do. But before that, let's store it in a string builder. SB new string builder. Now SB dot append this A and idx plus plus. If idx equal to n, just return. We first need to remove the last character. Wait, if wait. We can just put a check in here. If idx equal to n minus 1, just return sb dot append z and dot to string. Okay, this is the one edge case handled, and then once we have all the a's done, we while idx is less than n and s dot char at the current index. Wait, this is idx plus plus, no? Here we increment the value of idx by 1 while idx is less than n and idx of wait. It is less than n. What we do is if the current character, if s dot char at idx we extract this character and then what should we do? What do we do here? If sb dot append we do this minus a sb dot append character if ch is not equal to s dot char at I plus 1. This is idx. Now if then just simply break, else we need to increment. But before this, we need to check if idx plus 1 or idx is less than n minus 1.
I didn't understand that.
Oh, that, that was so scary. Oh my god. If this is true, then check, or we can just say plus 1. Yeah, if this is less than n, then check for the next character if both are equal or not. If they both are equal, just move on. Yeah, this makes sense. At the end, just return sp dot toString. Let's run this code. Let's see. Why can I not do this? Okay. Hmm. What is this? Okay, so the problem is coming after A. So problem is here. sp dot append. Can I not do this? Why can I not do this? sp dot append this. Why is it giving me garbage value? Or should I just do minus minus? Can I do that? What if I remove this? Yeah, fix the syntax. I want to find the sequel of this knowledge. I want to find the previous character. Hmm. Yeah, this makes sense. A minus one and not that, of course. If s dot char at idx equal to a, then just return, insert z else s dot, I'm not calling this again, right? I should add. Da, da, da. This is previous ch minus 1. Okay. Uh-huh. Previous. Da, do. What do you mean by that? Open book is bad again. Bad. Wow. Yeah. So should not be this. You should be good here. B. This is this. Yeah, and then file IDX is this. Then and just append. S dot char at IDX. Yeah. Need to check for A's, then if this is not same, just break. Oh my god. How do I forget this? Wait, will I find- Oh yeah, this should be rev. This is this. Okay. I- V A. Okay, if is not equal to this, or if rev is equal if this is equal to A, just break. Yeah, the next character is a just break here. Y to decremented to C. C, this is V, this is A. I am appending extra characters now. If this is the case, ID express this. A, B, A, wait, B, 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 if this is true, yeah, I wanted this speed dot caret minus one. Yeah, instead of checking this repeatedly, if LDX equal to 1, I return this. If not, if this and this, yeah, increment LDX. Otherwise, append that's what I'm doing here. And let's look at IDX. If the current character is not equal to A, we just do sp dot append character s dot char at IDX minus 1. If now while this is this, just append and also IDX plus plus. This is not equal to A. Just to freeze everything. As soon as you encounter A, just break and then print. Continuous, this makes sense. This is perfect. Did you convert it into array? Yeah, thought so. and wait for a minute. Okay, push. Okay, let's solve another problem. HTML entity parser. I guess I won't. I will not solve this problem. So okay. Mm. If the current character is not equal to A, we just do sp dot append character append and also ldx plus plus. Okay, Problem 1410 HTML entity parser. HTML entity parser is the parser that takes HTML code as input and replaces all the entities of the special characters by the character itself. Okay. The special character and their entities for HTML are for quotation mark, it is this single quote mark greater than sign. Given the input text string to the HTML parser, you have to implement the entity parser. Okay. While return the text after replacing the entity to the by the special characters. Okay. So it's pretty straightforward, pretty simple. We just need to check when this and starts, and we encounter an what do you call this a semicolon. We just store that value in a temporary string builder, and then compare that convert it into a string, then compare the string uh with this and this. If it matches, just append to our actual string builder these characters. It's pretty straightforward. Uh, for let's do while loop. Int n equal to text dot length while idx is less than n. Int idx equal to 0. If uh wait, character ch equal to s dot char at, let's just convert this into an array. That would be much better. A character array equal to text dot to char array while if array of idx equal to, and we'll just store this in a temporary string string builder sb equal to new, oh no, this is temp equal to new string builder temp while array of idx is not equal to what is this semicolon. Just start appending temp dot append this these characters array of idx, then just increment idx. Once we get our special characters or the entity, yeah, the special characters, we just check using if conditionals. If temp, wait, let's see how to check uh, a string builder with a string example ABC. Let's see. So I have to convert this to string. Yeah. Second down. Okay, so temp.toString dot equals, let's see, let's copy this. Is not equal to this, right? So we need to append temp dot append this character in IDX plus plus as well. If this equals to this, SB dot append this. What is SB? We can type in this. S SB equal to new SB. Okay. If else if just copy paste this. One, two, three, four. 1, 2, 3, 4. We can append an apostrophe. Wait, why can I not? Oh my god. Settings, keyboard. No. Extended. Yeah, use this. Oh, keyboard, select, remove this. Okay, yeah. Oh, thank god. Is this? char ch equal to this. What? How to schedule this is equals yeah, so I should just short fix like this. Correct. Oh, so we can write it like that. I thought we cannot write it like that. Ah, anyways, um, we have CT, CT, LT, LT, press, no, C, ampersand, we have greater than sign, less than sign, and a slash. If this is not true, then what should we do? Just append the character sp dot append the current character and then IDX plus plus. So the return sp dot to string of course and ambassador. Oh wait, if it doesn't match, just append the temp. And quote oh okay, my bad. Yeah, this should work. This is such an annoying problem. Yeah. The like should less than how many hours? Nope. Of course. And ambassador. Oh wait, if it doesn't match, just append the temp.
Hello everyone, in this video we are going to solve the problem HTML entity parser. The description says that HTML entity parser is the parser that takes HTML code in a list in this entire string. First we need to maintain a map. In the map we can store the entities and the corresponding special character. Now we can start reversing the text. As soon as we notice that every special entity, every entity starts with ampersand symbol. So as soon as we come to an ampersand symbol, we can maintain another temporary string s. In this we will keep incrementing. In this we will keep a semicolon, which is the end of the entity. So we will try to find this particular string s in our map. If we are able to find this in our map, we will add to our answer and then break. Else we will simply keep on adding, and as soon as we come to another ampersand, we are going to break out of this loop. So what I'm trying to say is, let's say we have ampersand abc ampersand gt then semicolon. Now in this example, we in our s we added till here. Ampersand abc is now our s. Now as soon as we come to another ampersand, we are going to break, and we will add s to our answer. So abc will be added to our answer. S semicolon. And in our, if the first start,
we have given. So here in this simple loop, I'm just
How is this still passing? This will fail on exactly the test case my code failed on.
after that I am just return type is a string, so that's why we have converted to full string. So this is a normal linear time complexity. We can solve this problem like if we miss the string.
Wait, we have a bi-weekly cadence? Ah, ah, okay. How do I have 5 views? The problem is I have attempted this now, so I need to submit the code. But this is an annoying problem for sure, not an easy problem. This is a stupid problem. Lord. Dude, come on. By the way, why did it fail that test case? Intuitive parsing. What was this and GT, something like that? Okay. If okay, so this is the error here. Into J equal to IDX. This is this J plus yeah. How about you? If this gets executed, we are fine, we are good. But if it doesn't, what do we do? Only if any one of this gets executed. Yeah, so I need a map. Don't even care at this point. I just need a map. What is this? Oops. Written down. Map. If map dot entity. If entities dot contain this stem, then sv dot append entities dot get them, and I rex becomes equal to j, Otherwise, we don't do anything. Right. That's key. Oh, okay. Days. Else IDX, yeah, else IDX remains at IDX. No, else IDX plus plus. Yep. No, yeah. Else sp dot append whatever that character is, array of IDX, and then IDX plus plus. If we find and the camder, oh, yeah, this should work. Entities dot get temp. What? Why did I open this? This was definitely an annoying problem. This is bi-weekly 171. Yeah, let's make it a top thing. Bi-weekly 171, where is it? Let's see, let's add this Chrome extension. Let's pin this. What? Where is the delta and all of that? Hello? No, I don't see this anywhere. Remove this. Rating character. Distance. Okay, anyways. $251 problem solved. Let's go. Now, what I want to see is I want to solve today's daily problem. I have not solved it yet. This is a pretty difficult problem as well. On partitions with maximum difference, most k. You are given an integer array nums and an integer k. Task is to partition nums into one or more non-empty contiguous segments such that each segment, the difference between its maximum and minimum elements is at most k. Under this condition, since the answer may be too large, return at modulo 10 power 9 plus 7. Nums into one or more non-empty contiguous segments such that each segment, the difference between the maximum elements is at most k. Okay, so we 9 comma 9 is 0. So it's what do you call it? Number of partitions will be 1 equal to 1. 9 minus 4 doesn't satisfy the condition. We move ahead. 9 minus 1. No. This is the maximum element, right? So we need to find more minimum element. Like we need to reduce this element. We move the left pointer. We are now at 4. 4 comma 1. What do we have? 4 comma 1. What does this mean? This means that we can have 4 comma 1 as one partition. We can have 4 comma 1 as one partition. Okay. What's this? Two concurrent viewers. Hmm. Let me check some things. Let's say the solution to this problem.
And understand the problem statement. And with that note, let's get started then. You're given two integer arrays, technique 1 and technique 2, each of length and represent the number of tasks to complete. Very, very important. There are n tasks we need to complete. Okay. Also, do let me know the feedback of I am using OneNote now. Is the previous thing better or this thing better? Do let me know in the comments. Okay. So, okay. If the IA task is completed using the technique 1, you earn technique I points. Okay. But yeah. And if it is complete using technique 2, you earn technique 2 I of points. You are given an integer k representing the complete one. One technique 2. Interesting that while you are
Just a minute to check something. Mm, mm,
but
Okay.
in a contest, right? Don't use this technique 1, technique 2. You can directly use T1. Like in the function, right? You can what you can do, you
Yeah.
can go to already shared with you. Remaining task may be completing using either technique. Return an integer denoting the maximum total points you can have. Right. Okay. After reading this, what intuition you get? Sayam, we firstly go to the constraints. Constraints told us that okay, it is 10 power 5. Perfect. Perfect k is also up to 10 power 5 range. It's less than n. So now let's try to think about. Many of the people may have thought about DP also. Let me to be very frank because I also thought about that. कि मैंने क्या सोचा that okay, we have two choices for each task. Either we can pick what uh either from T1, either from T1 or from T2. And but one more state we have to maintain that how many tasks we have completed using the T1 task. So we have to maintain another state
Mm,
k. And this will create a problem. That
mm,
first you can maintain the I task for which task you are currently at, and you have to maintain how many tasks you have completed using T1. So the total time complexity will be I into k means n into k, which won't suffice because it will lead to n square solution.
mm.
And we won't accept this. How can we make this better? This is our challenge, right? This is our challenge that will make things more clear. Create X is the it is very simple. Another greedy idea we can think of that what we can do, we can just sort it out what T1 and we will take max
But we cannot do
top.
that.
Why can't we do this? Let's try to understand that. Let's ask, but that is the point I want to make a greedy. So what we can do? What is the operation that will tell us that contribution from T1 also and T2 also? We have to pick from T1 definitely, but that is the point I want to make a greedy choice. That let's try to think of that's the difference because that is the trade-off, right? That will exactly tell me that what is the trade-off I'm currently doing. So what I will define another array. Let's say T, which will be what T1 of I minus T2 of I. Firstly, I did T1 of I because I have to take from T1. Pick top K from here. That is the idea. That is the idea. Why? Why it will work? See, means what? Have to pick at least K. Be very negative, and it will come at very later stage. So we won't contribute in our first K task from T1, right? I and T2. Yeah. So what we are essentially doing, okay, let me just make it larger. So what I'm trying to say is, now it's very interesting that how you can implement this, right? That is also the idea you can think of. Now, the interesting idea is you have to maintain the differences, but you also need to know the indexes also, right? Which task you've already done in the top K, because K are not the first K task. It already mentioned in the question. You can pick any K task. So what we did, we took the difference, we sort on the reverse, we did the first. The int is the idea.
Yeah. Just exactly. So, anyways, I need to solve this question. Somebody needs to explain this in a good way. And good story with Mike has not uploaded a video on that. Huh.
And we have a 4, meaning we need to remove this -1 fixed sum. Now this is 6, so let's go creating every possible right elements. This we also need to update to a system in and use model. And finally, we return dp and
If you guys haven't subscribed my YouTube channel, right? So in this problem, you are given an integer array nums and an integer k, right? Your task is to partition nums into one or more non-empty contiguous segments under this condition, right? And since the answer may be too large, we have to return it modulo 10 to the power 9 plus 7. Okay. So here, see this example number 1, right? So this is my nums array and k value, right? So in how how many different ways we can partition, right? So we can partition it like this, we can partition it like this, we can partition it like this, like this, like this, like this. So there are 6 valid partitions where the difference between the maximum and minimum elements in each segment is at most k, right? So here we can take individual elements, right? So here minimum element is 9, max element is also 9. So 9 minus 9 is 0, and 0 is difference is not greater than k of the maximum and minimum is the same element, right? So it is also valid. This is 9. Okay. So now how we are going to solve this, right? So let's do one thing. Let's take the same example number 1, right? So here, let's suppose you have just one element, right? Just one element. So tell me how many different partitions you can form until now, valid partitions, right? Which are ending at this 9, right? So only one, right? Only one is possible, right? That's it. Only one is possible. And how many empty you can form? Empty also you can form only one, right? If there are no elements, right? If there is only one element ending at 9, so only one you can form, right? Same way, how many valid partitions you can form ending at this 4, right? So valid one, right? So you can form this. This is one, right? This is one, right? So only one you can form, right? So one is just 9 and one is just 4, right? So only one is possible, right? So here min and max element is 9. Here also min and max element is 9, right? 4, right? So here also difference is 0. 0 is less than k, less than equal to k. Here also 0 is less than equal to k. So only one way is possible, right? Only one way is possible, right? 9 and 4, right? So here see 9 and 4 we can take individually everywhere, right? Until 4 ending at 4, not ending at 1, right? So this is what I'm saying. Okay, it will get more clear when I'm moving further, right? So here ending at 1, ending at 1. So ending at 1, see, this is valid 9, 4 and 1. This is valid 1, right? 9, 4, 1. Same way, this is also valid, right? 9 and 4, 1, right? This is also valid. So here, 2 ways, right? One is this way, individual elements if you pick until 3 now. This is 1, okay? Now and 3. So this is also valid, right? All these are valid, right? So 4 ways, okay? Now, ending at 7. Ending at 7. So ending at 7, here, you have 6 ways, right? These are the 6 ways. Ending at 7, okay? This is clear? These are the 6 ways, right? Here, ending at 7. So what I did step by step. If I have only until 9, if I have only until 4, if I have only until 1, if I have only until 3, and if I have only until 7. So until 7, 6 ways. Until this 3, 4 ways. Until this 1, 2 ways. Until this 4, 1 way. Until this 9, 1 way. And if we don't take any element, there is also 1 way, right? Empties are valid, only 1 way, right? Okay, this is clear. Now here, let's do one thing. Let's say this is nothing but my dp of 0, right? This is nothing but my dp of 1. This is nothing but my dp of 2. Okay, this is nothing but my dp of 3, right? Right. So here if I just write my dp array, right? Okay, 1 second. If I take 3, right? Right, this part is clear, right? How I'm filling this dp. Okay, now here dp is nothing but dp of I. Dp of I, it is nothing but the number of ways, number of valid ways, you can say, number of valid ways to partition nums from 0 to I minus 1, right? So here I minus 1. So dp of 1 means until 0 to 0, right? So only one element. dp of 2 means 0 to 1, that is nothing but 2 elements, right? 0 and 1. So here only one element I'm taking 0. Here I'm taking 0 to 1. Here I'm taking 0 to 2, right? This is nothing but 0 to 3. And here in dp of 5, I'm taking all the elements, right? 0 to 4 index, right? This index I'm saying 0, 1, 2, 3, 4. Okay. So this is nothing but your dp. Okay. Right. Now here, see, let's say you have 9, 4, 1, and 3. Okay. Until here. Until here, what is the value? Until here, what is the value? dp of 4, right? So 4, right? 4 is the value output, right? 4 ways. 4 valid ways. Combination with this 3 and 7, right? Right? I can take 7 individually, but I can also take 7 along with this, right? So, and for this 6, I'm doing this and this addition and that 6. For this 4, I'm doing these 3 addition and then I'm doing this, okay? And here it is clear, right, how I'm doing. But do I want to calculate all these values of n time, right? This can be very big. Here, I'm taking this of n. So, what I can do here, in this dp also, I can store the prefix sum. So, for ask you this, right, right, max, I told you that we have to keep the elements like this only, right?
Why did Code Story with Mike not upload a video on this problem? Anyways. Mm. Okay. Let's see. Maintaining decreasing maximum deck. Max deck is not okay. Maintaining increasing deck. Mhm. This was a pretty difficult problem. Very, very difficult problem. Let's see. Maximum number of coins you can get. 1561. 1561. There are 3n piles of. Okay. Problem 1561. Maximum number of coins you can get. There are 3n piles of coins of varying size. You and your friend will take piles of coins as follows. In each step, you will choose any 3 piles of coins, not necessarily consecutive. Is this a DP problem? Can be. Let's see. Of your choice. In each step, you will choose any 3 piles of coins, not any of your choice. Alice will pick the pile with the maximum number of coins. You will pick the next pile with the maximum number of coins. Your friend Bob will pick the last pile. Repeat until there are no more piles of coins. The 3n piles of coins of varying size will take piles of coins as follows. Given an array of integers piles, this is the number of coins in the ith pile. Return the maximum. Okay, return the number of coins that you can have. I can have. In each step, you will choose any 3 piles. Your choice. Alice will pick pile with the maximum number of coins. Okay, you will pick the next. You will pick the next pile with the maximum number of coins. I will pick the last. Return the maximum number of coins that you can have. Okay, could choose 2, 7, 8. Alice pick the pile with 8 coins. You we'll pick the 7, Bob, last one. Then 1, 2, 4. 2 plus 4. Here we'll have 4. Okay. This is a good one. Like an easy one, easiest on the easier side. We just sort the array. Dot sort files for int I equal to 0, I is less than n by 3, I plus plus. Now, what do we do here? Basically, choose, what do we say? N minus second, and then just decrement by 2, right? We first sort this array, we are at n minus 2, and then just add n minus 2 in total equal to 0. Nah, you cannot choose n minus 2 every single time, because from the beginning, the smallest file will be chosen by Bob. So, what are the number of choices we have, right? Number of choices will be n by 3. Yeah, so just go, yeah, in total plus equal to files n minus I minus 1. Return total. Great. Okay. Let's just see. System out or print and then or int I to see I plus plus this files of I, and then let's bring the elements. I should have done this right now. We get 7, we get 2. Oh, and plus equals 2. I did this in my mind, but didn't do it here. 7 and minus I minus 1. Oh, this should be 2. And minus I minus 2 is 7, 0. And then plus 2. So 2 and minus 2 is 1, 2, 3, 6 minus 2, 4. And 4 minus 2 again 2. So we are here. Yeah, this will work. 7. Why do we only take? Yeah, this should be equal to, and we should be good. Why? Sort this, we are at 8. Then choose 6. Wait, this. Then we choose 5. Oh, no. We are at 8. What's the length? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, this is 9. So, at the 0th index, I should just iterate int I. Why am I doing this? Int I equal to n minus 2. I is greater than equal to. Let's see. Now here n should be equal to n minus. Divide this into 3 segments. And I want to run this 3 times. I want to run this 3 times. So n minus n by 3. This is n and minus minus. Oh, minus equal to 2. Yeah. This doesn't even run now. Wait. Int that, or yeah, that, whatever. This should be here. Oh my god. Sorry. I we choose this. See, we have 2 options. Yeah, it doesn't matter if we go from the front or from the behind. What am I doing? Int I equal to 0. Int I equal to 1. I is less than. Wait. I is less than. No, you know what? This is equal to 0. This is the amount of time this will run. I plus plus. Now, int idx equal to 0. Total plus equal to files of idx. Now, idx plus equal to 2. idx starts from 1. Ah, how? 6 to 2 plus 3. Yeah, a sum of 3 obviously. 8 minus 3, which is 5. No, wait. What if I choose 9, 8? Yeah, 8, 6, 4, 8, 6. What? 8? Is this even 1, 2, 3? 1, 2, 3, and 1, 2, 3. Yes. So we choose 8 from here, 5 from here, and 2 from here. 8 plus 5 plus, yeah. How is this 18? Oh, wait. 2, 7, 8. Oh, wait. 8. Yeah, we just decrement by 2. Increment this by 2. LDX equals to 1 minus 2. Decremented by 2. Yeah. This works. Let's go. This was so slow on my part. This was just visualization thing. I could have been faster. And git commit. Git push. Oh wait, I didn't even submit this. Let's see, this will pass. Yeah. Right. Uh, let's see. I want to check the rankings again. Oh, great. 3,450. I take that. Smallest missing integer greater than sequential prefix. So, 2996. 2996. Oh, this is an easy problem. But the acceptance rate is 34%. Let's see what the comments say. They write a line. The prefix is what? So, the first given easy question without discussion. Is it? Given a 0. A prefix nouns is from this prefix is sequential if for all X is greater than equal to the sum of the longest sequential. The sum of 6 is not in the array, therefore 6 is okay. Is 2, 4, 5. Okay, let's see. Smallest problem 2996, smallest missing integer greater than sequential prefix sum. Okay. You are given a zero indexed array of integers nums. A prefix nums 0 to I is sequential if for all j which starts from 1 to I equal to I, nums of j equal to the previous element plus 1. Okay, basically it's in ascending order and uh, in in a sequence. Okay. In particular, the prefix consisting only of nums of 0 is sequential. The prefix consisting mm, prefix only nums of 0 is sequential. Okay, okay. This is an important line. Return the smallest integer x missing from nums such that x is greater than or equal to the sum. Well, the x is greater than or equal to the sum of the longest sequential prefix. So we have int min equal to integer dot max value. We should have an hash set for O of 1 lookups, hash set for int I equal to 0, I less than int n equal to nums dot length should be less than n, I plus plus set dot add this nums of I. Okay. Now we just iterate over. Since this is very low, I'm going for the n square solution. I plus plus for int j equal to I, j is less than n, j plus plus. Okay. So if at any point nums of, let's just first, yeah, if nums of I is not equal, nums of j minus nums of I, if this is not equal to 1, then just break. If it's equal to 1, we perform a few operations. If it's equal to 1, what do we do? We add it. Here we need to define int total, int temp equal to 0. Yeah, int sum. This is the temporary sum. Sum plus equal to, what is this? Nums of j. This, I believe this should be I plus 1. But let's see. Num is this. Let's see. Calculate the min. Then comma sum. And if, no, first we find the total sum and then see if sum is greater than, no, if sum is greater than equal to, we need to find the numbers. Need to first check if this sum is in the array or not. Is greater than, what is equal to, oh, the sum of the longest one missing from nums. We need to check. Oh, yeah. Set dot contains sum. If it doesn't contain the sum, then we check for min. Min comma, what is this sum? Okay, this should work. Return if min equal to this, then return nums of 0, else return min. Yeah. So is this, no, this should be, yes, of course. Of course. Why is it 0? We generate what, this is sum is equal to 6. If set dot contains sum, which it doesn't, wait, let's see. Because my solution is correct. I think I'm missing something very stupid. What is the error in my code? Wait, the prefix consisting only of nums 0 is sequential. The prefix. Wow. From 0. Okay, so this we just break int sum equal to 0, int sum is equal to, that is, this will be true only if nums of j is nums of j minus nums of j minus 1 equal to 1. That's when you add if this is not equal to 1, you break, otherwise just add up. Add the value of nums of j plus, yeah, this will be nums of 0. The value of nums of j if like, but if it doesn't contain, then check this. This should work, but let's see. Okay, down. Right side contains. Find the smallest integer that is greater than equal to sum that is not in nums. That is not in nums. Oh my god. Wow. This question is it's I agree the writer of this problem didn't do a great job at writing it. Yep. So while set dot contains sum, we just increment the value and at the end return sum. Return this should work. Of course. Git commit. Okay. How many fucking 253. Okay, okay. Oh, the charging is stopping. Matrix similarity after cyclic shifts. 2946. Nine. Again, an easy problem. Matrix similarity after cyclic shifts. This table. Okay, this is minus left shift. You are given an m plus n integer matrix Mac and an integer k. The matrix rules this happens when happens k times. The cycle shifting or index. Okay. Problem number 2946, matrix similarity after cyclic shifts. Okay. You are given an m cross n integer matrix Mac and an integer k. The matrix rows are 0 indexed. The following process happens k times. Okay. Even index rows are cyclically shifted to the left and all index rows are cyclically shifted to the right. Okay. Return true if the final modified matrix after k steps is identical to the original matrix and false otherwise. We just need to check if the mod of the length of the number of columns here is equal to mod of number of columns modded by k is equal to 0 or not. That's it. Return mat of 0 mod k equal to 0. Select that easy. No, it's not. 2, we have 3. Okay, oh, so this is in which case constraints are low as well. If okay, let's see. If it's 0, then just directly return return, yeah, sorry, true. But if it is not true, then we need to check whether or not all the elements there are equal or not in the given matrix. So for int I equal to 0, I less than n, I plus plus. For int j equal to 0, j less than n, j plus plus. Just check if this should be a minus. Just check if mat of I comma j is not equal to mat of I comma j plus 1. If this is true, return false. If not, return true. That's it. Of course, what is n? Mat dot int c equal to mat of 0 dot length of this is should be good. Why we have 2 k equal to 1 if this is an edge case. If k equal to 1, return true. Right. If we cyclically shift it only once. Wait, how? Yeah, this should be false. So this will be equal to 2, and then it will check if, yeah, this is not equal. Why is this outputting true? This should output false. 0th index, 0 and the next index, they are not equal, so return false. Short. What is wrong in my code? Why is it failing this test case? Why? Why is this wrong? This false. Or Yeah. Do I have to write this? So we have to do this manual code. K equal to K or C. And if K array equal to new int of C for int j equal to 0, j is less than C, j plus plus. If, no, if this are not 2 equal to 0, then we left shift. Yeah, we left shift. I j plus k. To left shift, to do a left shift, this should be j minus k. Right? If I is even, we need to left shift, right? This is right shifting, right? Yeah, before may minus one. I don't think so. First shifted of j should be equal to that of I and j minus k plus c mod c. Else shifting of j should be equal to that of I. Oh wait, no. This is the okay. I get j plus k mod c. Check. Now we just check for I equal to int k equal to 0, k less than c, k plus plus. If shift vector of I is not equal, k is not equal to mat of I of k, return false. Else return true. This should work. IJK very return sketch from my page. And closing this, let's see the second page. How many problems did we solve today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and daily problem which is 16. So good. And then 3 plus problems of the bi-weekly contest, 19 problems. Okay. Should I jump to 1450 or 1500? I think we solved 1450 questions, level questions. Now let's see how many we are able to solve. Then we'll jump on to 1500. But tomorrow, my goal is at least to start with code forces problems. Code forces, 800 rated problems. Yes. I mean, my goal for tomorrow is to solve code forces problems, 800 rated and 800 plus rated problems. Get good at solving those problems. Huh. Oh, it's 10:45 p.m. I stream for wow, so many hours. That's- Tomorrow I have LeetCode weekly contest. So let's see. I want to check before going. How many coins did I get? Store, redeem, 1508. But how many coins did I get for participating? Did I daily? Yeah. But wait a minute. I also participated in this contest, right? So I should get some coins, right? participated in bi-weekly plus weekly, you get 35. Participation is 5 points. So I'll get at least 40 points. One day I will be somewhere in this range. We'll get there. Only if I knew what Fenwick tree is and how to solve questions on Fenwick trees. I have two options. Tomorrow, let's just close this. Tomorrow either I can solve code forces problems or solve or learn a segment tree. I mean, I kind of know what segment trees are, how to implement it, but we'll learn in depth. I can do that, but I think I should solve code forces problems, right? Because on Monday and Tuesday I will not be here. I'm going out. So we'll solve code forces problems tomorrow and then see. Let's see. Huh. I should end the stream right now. I will end the stream right now. Bye bye.